Hello grade 12s, welcome to my channel, and let us have a look at this question paper and try to do it in its entirety as requested by one of my students. Actually, I've been trying to run away from it, but yeah, the request was put out. It's just that time is not on my side, guys. So to post as regularly as I used to, it's gonna be a bit challenging. It's even worse to do these long full papers. But let's have a look at this one and just to take you through it so that if you're a matriculant of 2025, you can see exactly what's coming for you at the end of the year, starting from the trial papers. This is the level that you need to reach so that you can move forward smoothly. Okay, we start with the instructions. Of course, we read all of them, but I put particular importance to instruction number 4, which says, in all calculations, you need to show diagrams, graphs. Most important is the etc. part. A lot of people ignore this because they don't think it's important. And this is these very small things that catch people out. Okay, and then the issue of how we round off. In this case, we're doing 2 decimal places unless otherwise stated. And then, of course, diagrams are not drawn to scale. It's a warning. We need to not read too much from the diagram per se, but it has to transmit the right information. Then, of course, there is formulae included at the end of this question paper should one forget a particular formula that is necessary. Okay, let's get to question 1. So I have done question 1 already. But we're going to do it again for just completeness sake. So 1.1, we're dealing with quadratics in different formats. Okay, so we're solving for x. Given x into x minus 3 is equal to 0. This is already factorized by taking out the highest common factor, so we can equate each factor to 0 and solve. This would mean x is going to be 3. So this one is an easy question, grade 9 thing. Nothing really out of the ordinary here. So we score those 2 marks. But do not forget, guys, to check these answers into the original. I know many people ignore this. Check answers whenever that is possible, okay? That is, plug the solution back into the original. If the left-hand side is equal to the right-hand side, it means the equation is balanced. So that means it's likely to be a correct answer, okay? If we place 0 there, we definitely get the balance. We put it 3, this becomes 0. So we still get the balance. So we know those answers are correct. Even as we proceed, we don't need a conviction otherwise. We don't even need to see the memo to be sure that we got it right. So the next one is 2x squared plus 1 is equal to 4x. Now we're told to do this to 2 decimal places. So this is already suggesting our quadratic is going to not have rational roots, meaning the roots are irrational. So we need to rationalize that denominator, because by rounding off, we're technically rationalizing the denominator. Anyway, let's have a look at this. This is going to have to be written in standard form. We transpose the 4x, then we add 1 so that we isolate the 0. So this is now in standard form. So we know that x, we always have to show the formula as per instructions. Whatever we have used to determine our answers, we need to show it. So minus b plus or minus the square root of b squared minus 4ac all over 2a. So we substitute into this formula. So we've got minus into minus 4. So what are we doing? Minus 4 is the coefficient of x. It becomes the b. Alright, so that's what we put in there. Plus or minus the square root of minus 4 squared minus 4 into, now a is the coefficient of the highest power, x squared, and that's what we're going to put for a. Okay, so this is 2 into, now c is the constant, and that's what we're going to place for c. Okay, so this is 1 all divided by 2 into 2. All right, now that a correct substitution has been made, it is up to you as a student to simplify that by sorting up the discriminant first or whatever. But for me, it's a waste of time. You may as well just jump in and start doing the things that must be done. Okay, so make sure the substitutions are performed correctly. Okay, so my answer on my calculator gives me 1,71 to 2 decimal places, or x. Of course, this is more of knowing how to use the calculator effectively, but you can still do completing the square here. It is one and the same thing as using the quadratic formula, because we learn that if we complete a square on a standard equation, a standard quadratic equation, we essentially end up with the quadratic formula. So that's how we do it. So those two are one and the same thing. So if you don't like the formula, you can use completing the square. Again, guys, be very careful. We need to check these solutions for correctness, in that, do they balance our equation? I mean, this one is a bit hectic. The best is to take that, but remember, this has to be correct. That has to be correct. You can use that if you like, or you can substitute into the original even. It's not a big deal. You can still use the original. Okay, so if we substitute these values there, we should have a balance. Of course, since we rationalize, that means we will have to round off to the nearest integer as well in there. So now this is a mark for correct substitutions, and usually writing in standard format is also a mark. Okay, so that's how we score those 4 marks here. And of course, we had 2 marks in the first one. So be in the habit of checking these answers, because it can be quite hurting to lose easy marks like this. So the next one is x squared minus 2x minus 3 to be greater than 0. This is a quadratic inequality, so we can factorize it. Usually we will succeed, but at times we may not. So if we don't succeed, then this would force us down the path of using the quadratic formula and perhaps round off to 2 decimal places. Remember, that is still on the cards, so don't be fooled. And then at this stage, guys, I want to use the graphical method. I have taught you guys how to do other means, so I'm going to stick to the best. This is the best, by the way. This is the best method to use. Okay, now let's see, what does our parabola look like? It looks like that. Okay, good. So we have minus 1 here and 3 and minus 3. So I always attempt to do a near perfect sketch to avoid issues, especially on topics that require an application of this situation right here. All right, so let's have a look. Now we're saying this quadratic or this parabola of ours must be greater than 0. So this means we want to read it here. So we want to read it on the x values that give us the positive y values, okay? So this means our solutions will be read nicely without including the critical values. So it's an open circle, and we move in that direction. And the same applies here. This is not included, not a heart, please. That is for weak boys who say they are romantic. It's only weak boys who are romantic, right? Yeah, real men are not going to follow that nonsense. Anyway, so we can make a conclusion that here x should be less than minus 1 or x should be greater than 3. But I feel it's always important to include this, because this answer is not complete if we don't say what this is. Okay, but some people may choose the interval method, which is okay because it is only acceptable if we're using this. But sometimes writing the domain for me when we wrote inequalities like this, it avoids the issue of not being specific. Because let's say, for example, our domain is natural numbers. Now, doing the interval notation would not make sense if we don't qualify that which is a variable is a set or is an element of a particular set of numbers, so that it can make sense to the reader. Remember, we are writing, this is a language, maths is a language. So it has to be understood for what it is. We should not be guessing. So these are the solutions, guys. And the factorization is usually what gives marks. How many marks here? 4. So the 4th mark could be the diagram, or it could be maybe stating the domain. It's not a problem. Next question, 1.1.3. We have 2 to the exponent 2x minus 2 to the exponent x plus 2 minus 32 equal to 0. Of course, this is yet another quadratic, but in exponential form. Okay, so we need to see what is the common one here. The common one is basically, well, not necessarily the common one, but the smallest power, if I was to put it, because of the exponential type of powers that we have here. What did I say? Of the powers that we have here, the highest in terms of the variables is 2 to the exponent 2x. But the smaller one is 2 to the exponent x. This is when we're talking about the algebraic ones. The arithmetic one, which is 32, we don't really mind, okay? So let's write this in such a way that we can see this. This is 2 to the exponent x all squared. Now we can see this is a quadratic because the highest power is in the second order. Now we split this. It's going to be 2 to the exponent x times 2 squared. This is using exponential rules. Now we can see this is panning out nicely. So this is 2 to the exponent x all squared minus, we simplify this. This is 4 times 2 to the exponent x minus 32 equal to 0. Now we can factorize here. Of course, a student who doesn't like this here can use the so-called K method. Okay, this is just calling, for example, 2 to the exponent x k, and then we can see a quadratic nicely. But you need to see maths for what it is, guys. learn to do this, you will thank me later. 2 to the exponent x. Now factors of 32, the brackets are not equal, obviously. The biggest is going to be 8, the smallest is 4, because the difference gives us 4. So this implies that 2 to the exponent x is minus 4. This is never the case, right? So we can strike that. We can never have a positive power to a variable, that has a variable exponent, giving us a negative answer. It never happens. This can only happen if we multiply this entire power by a negative. But if it is positive itself, it cannot give us a negative answer. Or 2 to the exponent x is 8. Okay, we can see that, well, the key is base 2. Can we express 8 as a power of base 2? The answer is yes. So we can say 2 to the exponent x is equal to 2 cubed. Now once we've got powers with the same base that are equal, it means the exponents are also equal. Okay, that's our solution right there. But as I said, guys, do not forget to check the solution in the original. Now let's see, how do we get marks? Of course, we get a mark for this. Right, we will get a mark for rejecting that answer. Usually this is algebra, so any algebraic technique of some sort or conclusion is usually mark worthy. Whenever we factorize, remember the 3-step approach? Yes, this is it. That's actually what we do in maths when we solve. Now we can say, okay, we've got how many marks here? 1, 2, 3. Sometimes writing in standard form, that could be the 4th mark. How many marks are these? 5. Wow. Okay, so when we make a rule, maybe changing that 8 into what that is, this is what these 5 marks can be. But remember, guys, this is just me proposing the marking guidelines. Of course, to try and highlight the areas that you need to pay attention to as a student when answering in an exam. Because if it happens a mistake has occurred and you end up with the wrong answer, some steps that you carefully performed may be your absolution in not getting a 0 in that question. And who knows, that could be the difference between a pass and a fail, a distinction and a decent mark. Okay, so remember those kind of things, because the impact on your future. But like I said, we always take the solution and put it into the original to check if we haven't performed a mistake. Because if it ties up, provided our original expression is copied correctly, then it means we performed the correct gymnastics. All right, so if we put a 3 in there, we get 2 to the exponent 6. That's 64. And then we put a 3 in there, we get 3 plus 2, that's 5. 2 to the exponent 5, that's 32. So 64 minus 32 is 32. 32 minus 32 is 0. So the left-hand side is equal to the right-hand side. And that confirms that our gymnastics were proper, okay? At least we can accept that. Yes, we may have done some illegal things, but this is convincing enough to not waste time worrying on whether this is correct or not. 1.1.4. Now let's deal with this one. Goodness, what did I do here? I wrote 1.1.3 twice, okay? Apologies for that. Okay, so let's do this one. It's a radical or quadratic in set form. This is minus 2x plus 4 minus x is equal to 2. Of course, we know that when we solve here, we isolate our radical. So this is minus 2x plus 4 equals, we transpose x. It's best if we write it that way. And then the gymnastic of choice here is to undo the square root sign. Remember, 3-step approach, BODMAS is looked at in reverse, or we call inverse operations. That's what we're dealing with here. So when we do that, we essentially take out the root, and here we square as we know how, by applying the distributive law, or FOIL method if you call it. So this is x squared plus 4x plus 4. Again, one has to be proficient with this because it is studied as early as grade 9 currently. This used to be a grade 10 thing. Anyway, so it doesn't matter what it is. What we can see immediately is that 4 and 4 should cancel because they're of the same sign on either side of the equal sign. Now if we write our quadratic in standard form, we get x squared. We transpose the 2 there, we get plus 6x is equal to 0. And then we factorize by taking out the highest common factor. And then we get what we get. All right, okay. And so we can see that from here, x is either 0 or x is minus 6. Now, this one, even if you didn't like to, it compels us to do the check. Of course, this should be a standard approach for a mathematical, should I say mathematics student. If you don't check your answers, then you are ridiculous because you're just going to go and flop something that you know by just allowing mistakes to dictate how much you should get. You should avoid that. Don't let mistakes decide your fate, okay? Double check things so that mistakes are found early, because even in real life, you will still make mistakes. But if you check them early, the consequences are smaller and perhaps insignificant. But if you let this run its full measure or its time, then there will be tears. So you don't want to do such things, okay? So here's the thing. We need to check by placing 0 back into the original. Please, the original must be copied correctly if you copy it. Luckily, these days you are given this answer book that already has these expressions written, so you just have to deal with them. I hope so. I don't know. Anyway, when we put 0 there, you just end up with the square root of 4. Square root of 4 is 2. 0 there means this is gone. So 2 is equal to 2. So this means this checks out. We put a minus 6. We get 12 plus 4, that's 16. Square root of 16 is 4. We put a minus 6 there, we get a plus 6. So 4 plus 6 is 10. Certainly 10 is not equal to 2. So this solution must be rejected. Just strike it like that. Again, this is algebra. Doing so is important. And whenever we factorize, it's part of the 3-step approach, and that's how we score marks, okay? So as much as the 3-step approach is more directive as to what we do when we solve, at the same time it dictates where we get the marks. All right, so don't take it lightly. It's not a joke, guys. Maybe some sort of an invention if you think about it, or an obsession of my own, or many others who thought about it. It was quite surprising actually to find someone using that without really calling it what I called it, but yeah, that was very inspirational. Sometimes you think you're dreaming or you're crazy, but you only realize that you're just not so far off from what is right. Anyway, that's me just trying to give myself a pat on the back. Yeah, who's going to do it if I don't do it? Anyway, guys, this is a gymnastic also. This is some technique or law, if you think about it. The 3rd step, if we can consider that, or just BODMAS, the reverse operations. If we're applying them, we get a mark. When we do them directly, then we don't, okay? So that's the thing. Anyway, so the mark could also be here, writing our quadratic in standard form. Remember, algebra, it's all about standard stuff. Anyway, guys, this is 4 marks. How many marks were there? 4, yes. Okay, so let's go through the next one, which is 1.2. Now 1.2, it's simultaneous equations, a very important topic in maths. So we've got 2x plus y equals 3. This implies that y is equal to minus 2x plus 3. That we can call equation 1. We were given also an equation of y squared plus xy equals 2. Alright, so this is more like an ellipsoid of some sort. Now we can make that equation 2. So of course the next step is to put 1 into 2. Okay, now we will see why we substitute that expression. 2x plus 3, then we square it, we follow the rule written. Again, minus 2x plus 3 is equal to 2. Then we simplify. This is going to be 4x squared minus, this is 6 by 2, that's 12, plus 9. We sort this out, it becomes minus 2x squared plus 3x. We can transpose that 2 quickly so that we don't waste time. Now we handle the like terms. This gives us 2x squared. Okay, minus 12x plus 3x gives us minus 9x. And then 9 and minus 2 gives us plus 7 is equal to 0. Okay, we can attempt to factorize this. I mean, if by now you are not comfortable with factorization, please kill yourself, okay? Ndiyacela mntwana esikolo, zibulale ngoba awukho serious. Okay, this needs to be second nature, guys. Should not be struggling here. So this means x must be 7 over 2, or x should be equal to 1. Okay, maybe it's too far off. Nice and easy. So that means y is equal to, now we substitute these values into the original. I mean this equation 1. So this is going to be minus 2 into 7 over 2 plus 3, or y. It's going to be minus 2 into 1 plus 3. What is that? This is out. Then 7 minus 7 plus 3, it's minus 4. This is just going to be 1. Now, like I said, guys, we must take the originals when checking these answers. Okay, we've got to check these answers. Whenever we have an equation, if we're solving an equation, it means we can check the answers. Okay, please do that. Where we cannot check, please make sure the procedure, formula, substitution, and answer are all tying up. Okay, there mustn't be craziness. If you have to run it twice, please do. Okay, let's put the set over there. So 7 over 2, the 2's cancel, will remain with 7. Then we put minus 4 there. So 7 minus 4 is 3. So this means the left hand side is equal to the right hand side. So this set passes. Alright, we put a 1 there. This is 2 plus 1, that's 3. So this also passes. Be very careful never to check the answers onto a manipulated equation. Only check on the originals, okay? Because if you manipulate this wrongly, the answers will tie up with that equation because they came from it. But they may be wrong for the original, okay? Be very, very, very careful. Again, guys, when we substitute one into the other, the act of substituting is usually given a mark because it has to be a correct substitution. It can't just be a substitution. It must be a correct substitution. Alright, so that's the one about 1.2. So let's do 1.3. 1.3, we're given this product of 1 plus a half into 1, plus a third into 1 plus a quarter. And we're told this product is going to continue in this manner. Remember, in maths, it is standard to show 3 terms or 3 things in a pattern so that we can prove that that pattern goes that way. Okay, usually that's the indication. So you need to understand mathematical notations. We're told each factor is in this product form. Okay, so we can see that n is the variable and it follows the natural numbers from 2, 3, 4, and we were told n is greater than or equal to 2, and we can see it started with 2 and it kept on increasing, but it's a natural number. So we can almost picture what this should look like before the end, however it is or wherever it is. So this is going to be 1 plus 1 over n minus 1. Now the knowledge of sequences and series shows here. If you don't know them, then you get shown out. This is why sometimes the proofs of those sequences and series, as much as they may not be examinable, sometimes understanding them is what matters. And I can tell you guys, if you don't know how to deal with these higher order questions, especially those of this nature, you're going to fail at university, because you'll be mostly dealing with issues that actually come out of these kinds of concepts, because these are definitions by nature. So you'll be dealing with definitions, doing proofs, it's not really that technical if you have been paying attention and taking every opportunity to learn. But if you're selective in how you learn, you'll always be surprised by things. Okay, now I have given you a video, guys, on sequences and series, and I've shown you how things work in sequences and series, because there you're dealing with long things where you cannot necessarily determine the end, but you can picture, or even the end is probably somewhere far away. There's a lot in between. Now you need to be comfortable with the pattern, you need to be comfortable with the procedure and how this thing is structured so that you can work with it nicely. Okay, so this must be equal to. So the question says we need to determine all the values of n for which the product will be an integer value. Okay, so obviously natural numbers, because this is already greater than or equal to 2. So these are positive integers, basically. All right, but now what do we do, guys? 3-step approach. We see brackets, we deal with brackets. We first simplify. But now these are complex brackets, so we can't just deal with it nicely as we wish. So what we want to do, we just first sort this out. Multiply the 2 there, we get a 2 plus 1, that's a 3 over 2. Again, guys, dealing with fractions is something that a student needs to be proficient with. If not, it's a serious danger. Okay, again, I multiply the 3 there, it's a 3 plus 1, that's a 4 over 3. Okay, deal with fractions however you were taught, but there are some quick techniques that sometimes are very useful if you know how to use them. 4 there plus 1, that's going to be 5 over 4. Then this keeps on going. Now if we sort this out to multiply, there's going to be n minus 1 plus 1. It's just going to give us n over n minus 1. Okay, into we multiply n, there's going to be n plus 1 over n. So this is it. Can you see? A very long thing. We made it nice and easy to see. Now what do we notice? As we're going to perform our BODMAS directly now, brackets multiplying this and that does that. This 5 is going to be taken by something there. This one is going to be taken by something there. This one goes. Now again, this whole cancellation of some aspects of this expression, the telescoping effect of these things, again, it comes from knowing those proofs. If you don't know those proofs, you would not know that this happens. Because it would say, yes, I see this happens here, but what happened in between? And in fact, what happened to the n minus 1? Because it looks like the odd one out. This is when you've reached the level of comfortability with handling algebraic expressions. Of course, understanding those proofs. Now we can see everything in the numerator is 1 except n plus 1. So this is what we end up with, divided by the denominators. Again, they disappear into just 1. That product only leaves a 2. So can you see a very complex thing narrows down to just a simple expression. Now this expression, we can look at it by inspection and determine which direction it should go. Remember, remember the denominator now, for us to get an integer becomes the most important. It already tells us that the numerator, whatever it is, must be a multiple of 2. But if we're looking at 1, it's already an odd number. Now, if you don't understand natural numbers, integers, whole numbers, rational numbers, you don't know odd numbers, you don't know even numbers, this whole thing becomes overwhelming. But if you've been watching the videos in this channel, and many other channels, of course, but I tend to be the guy who likes to talk too much, and at times I drop all these very important things in trying to make an idea clearer. And in that manner, I have given you a chance, guys, to kill these questions. If you've been watching my channel, say from 2022, if you've been upgrading, this question should have been easy, because it's similar to a question from the Northwest in one of the trial papers. Don't remember though, it was 2020, was it 2022? Yeah, I think so. There was a question of this nature, or 2023, somewhere there. Now, these are some of the things that as a student you will not be taught in class, for sure. But you have been taught before, although not in this sense. Now, it is upon you as a student to make the connections, because at the end of the day, we cannot teach you everything. You have to learn from what we can give you and expand on it by exploring around it. This is why I always promote the idea of doing the practice, trying it in as many ways as you can. See where the flaws are in certain approaches. See where the strengths are in certain approaches, so that as you move along, you don't run out of ideas of checking what would work and what would not work, even if it's something you're seeing for the first time. Now we can see if this is odd, an odd number plus another odd number gives us an even number. For example, take 1 and 1. We get a 2. Take 1 and 3, we get a 4. Take 3 and 2, we get a 5. Now, can you see an odd plus even gives us an odd number? But an odd number plus another odd number, say 7 plus 3, we get a 10. So we get an even number. So it means n must also be an odd number for that numerator to become a multiple of 2. Now, from here, we can say, therefore, n must be equal to this set of numbers. Now, can we put a 2 there? The answer is no, because we want an odd number to add to another odd number to give us a multiple of 2. So it's going to start from 3, 4, no, not 4, but 5, 7. Now, once we write 3, we can say this whole thing goes on in this manner. Okay. And that's it, guys. We are done. See, again, the answer looks a bit vague for someone who expects like 4 or 5 answers. But here the answers are innumerable. But we needed to identify that these are all odd numbers, okay? Exactly. All right, guys, so this is a very smart question, truly. For me, the simplification is mark-worthy, right? Narrowing it down to that expression is mark-worthy, and getting us that answer is perhaps how those 3 marks are scored. Okay, I'm taking it slow here, guys, because there's no point in doing this review and just rush for answers. Because if you don't understand the mechanisms involved here, the processes that are taking place, then what's the point? Because a memorandum is going to be published. You may as well just wait until it comes and look at it. But if you want to learn, because the memo doesn't talk, they don't tell you the logic behind some of the things you will come across in there. Now, this is the opportunity for a student to fully understand each approach and exactly its intent. All right. So yes, guys, you may hate me for these long videos. I know many of you don't like them, and this is why they are suddenly not doing so well, because most of us want some quick fixes. The problem is, guys, you may be a smart student, one of those who get straight A's. It's not a problem. You may just want to see the answers. But what about other students who are still struggling, but they want to get better? We need to accommodate them. So, and there's many of them compared to the smart ones. So we may as well accommodate the ones in the majority. And the ones in the minority, they can decide what they want to do. Although we are really thinking of them, because the other purpose of doing these videos, I mean, the way I do it, or my way of doing it, is such that a strong student gets stronger, okay? A weak student may still find it difficult to keep up, because I say a lot of things and they're not ready for this. But you will see when you get to varsity, you will see that lecturers, you know, they lecture. The lecturers, they lecture. They don't teach. So forget it. If you can't keep up right now, because I'm almost like doing more than just teaching for you guys. I'm doing a bit of both, because I'm saying a lot of things at the same time giving you the standard stuff. Lecturers tend to say a lot of things while they assume you know the standards, and you will suffer there, believe me. So this is again a way of me preparing you for even beyond just matric, because I realized how my biology teacher taught us. He literally lectured us in matric from grade 10, from grade 11. He was doing grade 11s and grade 12s. From grade 11, he would be like, I'm going to put the skeleton on the board, meaning he would give you some structure there. Then you go and fill in with the meat. He would say that, meaning you go and read and fill up. The notes would be incomplete with gaps, dashes and stuff. You would have to go and read that textbook and fill up those, because he wanted us to learn to see how to do things ourselves. Of course, he made a bit of an effort in helping us, but he actually helped us help ourselves. So how you are taught these days, guys, you're spoon-fed, which is the problem. That's why many of you struggle with these things, because you expect to be spoon-fed. And like a spoon-fed kid, when that thing doesn't want to open up their mouth, guess what? It won't. When it doesn't want to swallow, it won't. But a kid who went for the spoon, he's definitely going to scoop on the dish and put in the mouth and eat and swallow, because they know why they even took an effort to pick up the spoon. But someone who's being spoon-fed, they tend to be snobbish, because they will eat when they like, they won't eat when they like. They will not like what they're being fed. They may like what they're being fed. They may toy with it because they take it for granted. But those that know it took an effort on their part to get somewhere, they always succeed, because their whole action is called directed. Anyway, guys, let's not preach. Anyway, I've done these questions so I can spend a bit of time with you guys. So let's get to question 2. Now, question 2, guys, we've done and discussed as well, sequences and series. So 2.1, we're told the first term of an arithmetic series is 7. So we have an arithmetic series with the first term as 7. And the common difference of this series is 5. If the common difference is 5, the next term is going to be 7 plus 5, which is 12. The next term is 12 plus 5, which is 17, plus, and then the series keeps on going. This captures the fact that D is 5, because we know that the difference between any two consecutive terms here is going to give us 5. Okay. And we're told there are 20 terms in this sequence. Okay, now we don't really care about the term number 20. The first question says 2.1.1. Calculate the sum of this series. So we know that Sn is going to be n over 2 into 2a plus n minus 1 times d. This is the best formula. Of course, one can still do the Tn, find the last term, and then do that formula that says Sn is equal to n over 2 into a plus l, which is the last term. It's not a big deal. So this implies that S20 is going to be equal to 20 divided by 2 into 2 multiplied by 7 plus 20 minus 1 times 5. Okay, now let's get it done. So this is easy, guys. Now this is like grade 10 stuff, because I see you guys as early as grade 10 you do this kind of stuff. So this is more like a grade 10 question at this stage. So there's no excuse in failing it. So I'm getting 20, 40. Of course, I don't know what is what, but I'm gonna take it anyway. All right, not a problem. So usually here, this is a mark is on the substitution, provided it's correct and the answer. Okay, so this is a very simple question. 2.1.2 says now the original arithmetic series is n is extended to 75 terms. Okay, now the sum of these terms, the sum of these 75 terms is 14,400. Okay, now we are told here that we need to use sigma notation. Using sigma notation, write down an equation for the sum of the terms added to the original series. Now, not just any terms, but the terms that are added. So, using sigma notation, we need to write down an equation for the sum of the terms added to the original. You see, now this statement for me is unclear, because as a student I would give two answers here. Because I'm not sure if the question is saying only the terms added, not the previous terms that we dealt with, or is it saying we need to do the sum of the terms added to the original, meaning all of them together. So questions like these, I blame the quality assurer. Of course, I may be stupid to say this, but for me, quality assurance is not being done, to be honest, because if it was, this could be picked up that a student may get two ideas here, because this statement is not exactly decisive as to what it wants. It depends on whether you guessed it right or you picked the right one of the two. For me, it sounds like all of them added, or maybe just the terms that were added to the original only. Because at some point, certain things need to be put like only, because then we would know that that qualification is telling us that these are the terms that are added only, you know. But now if you just write like that, and now that statement is ambiguous, in my opinion. It's not just, unilateral. So anyway, I have done a video before and I've shown you how to do it if we're considering all those terms. But now let me show you in the other way, because this is most likely the way that this question is asked. Now remember, we had 20 terms, so that means the extra terms is going to be the term number 21 until term 71. So we may just want to deal with this and say, fine, what we want here is to say what is term number 21. Of course, we start with our formula Tn equals A plus n minus 1 times d. This implies that term 21, because this is going to be the first term of these other terms. So it's going to be A, which was 7. Remember, this 7 was the very first term. And this is 21 minus 1 times 5. Therefore, term number 21 is, let's see, 7 plus 21 minus 1 times 5. I'm getting 107. Okay, so this would be the first term of this series of these extra terms, because this is what I'm picking up. Although the statement is not really suggesting this is the only thing that is being said. So for me, students who answer whether putting all of them together or not, I would not mark them down, because this is something that doesn't make sense. Because I mean, for me, quality assurance should be a person who's going to read and attempt these questions themselves. They can't just take this and take the memo and that's it. They must attempt these questions outside the memo and see what is the problem, so that when this is presented to students, there's no questions as to what is meant to be what. Everything is clear. In any case, guys, let's forget about it. Now we want the general term. You can say also, we understand that Tn is going to be A plus n minus 1 times d. Now the first term is 107. Therefore, Tn for these terms, remember we're only talking about these other terms now. It has to be the sum of those terms, starting from term 21. So it's going to be 107 minus 5. So it's 102, right? So this is going to be 5n plus 102. I don't know why I went to the calculator. We can say then sigma, starting from n equals to 21 to 75 of 5n plus 102 must be equal to, it's going to be this total now, which is 14,400 minus what we got before. Okay, therefore we know that the sigma here of 75 terms of 5n plus 102 should be equal to 14,400 minus 2040. It gives us 12,360. Okay, guys, so I believe this was the question being asked. Could be wrong. But when the statement is not so clear, it doesn't make sense, honestly, to say this is the only way. Yes, the memo would say whatever the examiner had in mind, but this is not clearly communicated to a student. And remember, when we write these things, it has to be something that makes sense to any student. The student has to fail to generate the knowledge required, but the student must not fail to understand what the question means. These are some of the things I seem to see. We always judge and say our students are not performing well, but we are forgetting that the way we examine these guys, we first confuse them, which is a problem because we are not clear enough. At the same time, we know that the whole subject is technical in nature. Even the knowledge, we cannot be so sure that it was done correctly for that particular student. So in any case, for me, it's not an issue of language being misunderstood, but I think it's just the technicalities of the use of the language itself. Because even if we can use our own mother tongue, if I decide to use the higher grade Xhosa, still a Xhosa speaking individual may fail to understand what to do there. So there's no guarantee that if we use our own mother tongues in studying these STEM subjects, we are certainly going to perform better. No, that's gibberish. Believe me, it's nonsense. No matter who says it and no matter from what angle, there's no way that would make sense, because even to English speakers, math is still a problem. They are not excelling in it. So why are they not excelling? Why are they not all? I mean, look at the top students currently in the country. Did you see mainly white people there? Because they speak English and therefore they should understand this? The answer was no. So why was it not the case? Then this already goes back to telling you that this has nothing to do with the language. It has to do with the understanding, the way it was taught and the way it's received, whether the student does their own part as well. But yeah, the issue of use of language for me is what I feel should be coordinated, because there's a tendency for people to just use very vague language. Even if you use vague language, it's okay, because this is part of tricking an exam. I mean, making a question a higher order perhaps. But then there can't be two things interpreted from that question. We should be able to at least see one thing, perhaps be stuck in not knowing what to do about it. But having known that there was nothing else we could think of, okay? So that is the coordination process for me. Things need to be clear enough for someone to understand before you can say they have failed. Because how do you judge that they have failed because they don't know enough, when you yourself have not been clear enough? You get it? So anyway, we can debate this until the end of time. This is one debate that will never escape us, whether we like it or not. Anyway, let's have a look at this. We'll still hear nonsense being spewed all around us, and because of the so-called experts, I hate that word, by the way, because experts in what regard? Because we keep on saying experts. Remember during the COVID saga, we were told the experts say. But if we had the experts, how the heck did they not find the solution to this thing? Instead, they just seemingly somehow understood the natural history of the disease, but they didn't know what to do about it. But I mean, how many diseases do we know now and understand their natural histories, and we even have solutions because of that understanding? How then do we understand this one, but we don't know what to do about it? You see how ridiculous sometimes people can be, and we salute them as the experts. But they are the experts of nonsense, because this is just experts of common sense. They were not saying anything more than common sense during that time. In my opinion, everybody was an expert then. Anyway, let's leave that, guys, before I start offending folks. I think calculating this is a mark and the left-hand side. And of course, it has to be correct. The starting, the sigma sign, the end, and the general formula there. I suppose this is how those 4 marks are scored, guys. Correct me if I'm wrong. Of course, ask a question if you're not following. Let's move on. 2.2. 2.2 says, the sequence of the first differences of a quadratic pattern is like that. So we've got a quadratic pattern. Just going to say T1, T2, T3, T4, and this continues. We know that between these two, we have our first difference. Between these two, we have our second difference. Not second difference, but the second term of the first differences. Third term. And this will follow that pattern as well. But since we know that this is a quadratic pattern, we know that we will have a second difference. This is 2. Okay, we don't need to be invited to do this. It has to be second nature, okay? Now we are told if T99 of this quadratic pattern is 9632. So this is now T99. So this is 9632. Okay. Now we can assume this ends here because nobody told us anything further. This is going to be T98 before that. Okay. Great. Now we need to calculate the value of T98. Okay, so if we notice here, look at T1. T1 coincides, or at least leads us to the first term of the first differences. So this already tells us that here also, if we look at the difference between these two, this should give us T98 of the first differences. Okay? So already we know that if we find this term using the first differences, we will definitely know the difference between these two, and so we can find that T98. So this is very easy. I mean, this is a question that has been showing up multiple times in the past in different formats, so students should find it easy to deal with this one. So let's answer some questions. So 2.2.1, we know first of all that Tn, we're going to show which formula we are using. It's going to be A plus n minus 1 times d. This implies that T98, this is the arithmetic sequence, and we know it's a sequence of the first differences. So plus 98 minus 1 times 2. Therefore, T98 is equal to I could have done this in one step, you know, but I don't really fancy doing this like that, because I could have done it in just one step, but let's leave that for now. Yeah, let's just leave it at that because it's a bit controversial anyway already. So this is 1 plus 98 minus 2, no, minus 1 into 2. This gives us 195. Now we can say then, we know that T99, let's not even waste time here. We know that 9632 minus T98 in the quadratic should give us 195. That's why I said I could easily have just done this, and then on this side I write that formula. Then we sort it out just in a single step, but it's not a big deal. Therefore, T98 is going to be that 9632 minus 195. So this is 9437. Okay. Now, with these kinds of calculations, guys, it's a matter of making sure that substitutions are correct and the answer is correct, or it ties up to the substitutions, because there's no way we can prove this not knowing what it was, okay? Or at least so far, there's no easy way of proving that. And then, of course, the last one is that one. So this is how we score those 3 marks. So let's move on. 2.2.2. It is further given that the third term of the pattern is 32. So this is 32. And we need to determine the general term of the quadratic pattern. So that's not a problem. We know that 2a is 2. Therefore, a is going to be 1. Remember, this is 2a. This is 3a plus b, giving us that very first term. And the first one is a plus b plus c. We need to know that. Okay, so this also implies that 3 into 1 plus b is equal to 1. Therefore, b is minus 2. Okay, we can say then, maybe let's stop there and say then, we know that T3 is going to be 3, no. We can say with Tn equal to an squared plus bn plus c. T3 is going to be, a is 1, so this is just 1 into 3 squared plus, okay, maybe let's not, this is going to be minus 2 into 3 plus c. Now T3 is what? Is 32. Maybe I should have written 32 here. So 32 is equal to 9 minus 6 plus c. Therefore c is, so this is 32 minus 3 gives us 29. Therefore Tn is going to be n squared minus 2n plus 29. Now that would be the general term of the quadratic. But remember guys, we need to check it. Let's see if T98 is the value that we got above. So we have 98 squared minus 2 into 98 plus 29. I'm getting 9437. So now this confirms that that calculation is good. Let's see if we check T3. Sometimes checking non-contiguous terms, I'm getting 32, so that should be representative, but let's just do one last check and check the last term. T99. And we're getting 9632, so this means all that we did is good. Can you see guys, the examiners are very kind. They provide a way of checking things. So the A value, it's a mark. B value, it's a mark. Substituting there, it's a mark. Getting C, it's a mark. 1, 2, 3, 4. And then of course, this gives us the 5th mark. Okay. Very easy. 14 marks guys to score here. Not anything difficult at all. Okay, let's get to question 3. So question 3, we are told a circle with radius 6 centimeters is drawn. A second smaller circle is drawn through the center of the first circle. So this means this is the radius right here of the first 6 centimeters, and through that center we drew a second circle, okay, as shown, that touches the first circle internally. Now remember, this diameter is 6, right? So its radius is going to be half of its diameter, so that should be 6 divided by 2. That gives us 3 centimeters. Okay, a third smaller circle is drawn through the center of the second circle and touches the second circle internally. Again, this is part of the radius of this bigger one, and that becomes the diameter of this other one. So if we can just imagine ourselves where that center is, then we can draw ourselves a radius. So that radius is 1,5 centimeters. Okay, half of 3. So this is what we can gather from what we are given. Now we are told here that the process of drawing the circles continues and forms a geometric pattern. So this could have been ignored to make it hard, but it's being volunteered to simplify this question. Now we're told to write down the radius of the third circle. Remember, write down. 3.1, we've already done it. It's 1,5 centimeters. Please don't forget that unit. If you don't write it down, you lose the 2 marks. You lose 1 mark. Okay, so 3.2. Calculate the sum of the areas of the first 10 circles. So this is easy. So we know that the areas are in this format. This is pi r squared. So this is pi 6 squared. Okay, not plus, but it's a sequence. Then the next one is pi 3 squared. The next one is pi 1,5 squared. And then we were told this continues like that. Now, if anything is related to these circles, that is radius or diameters, they will form a geometric pattern. I can already see that r here is going to be pi 3 squared divided by pi 6 squared. Now this is 9 over 36, which is 1 over 4. It's a quarter. Easy. All right. Okay, so let's see. Am I right? 9 divided by 36, it's a quarter, yes. Because the pi will disappear there. And whatever happens next is anybody's guess. Now we want the sum. This is a geometric thing, so we know that Sn is going to be equal to A into 1 minus r to the n, all divided by 1 minus r. This is because r is less than 1, okay? This implies that S10 is going to be A, it's pi 6 squared into 1 minus a quarter to the 10, all divided by 1 minus a quarter. Therefore, S10 is what we will get. So this is shift pi into 6 squared into 1 minus a quarter to the 10 divided by 1 minus a quarter. Okay, so what I'm getting here is 150 to 2 decimal places, 80 centimeters squared. Remember, area is 2 centimeters squared. So again, this becomes a critical moment. If this is not written correctly, a mark is lost. So this is easy. Substitutions, they must be correct. The answer has to be correct. Common ratio has to be correct. And getting our A value here is what matters. But also writing this up could be considered for a mark. But I believe that's how we score those 4 marks. So 3.3. Now the next question says, which circle has a diameter of 3 over 128 centimeters? So we can say the diameters are in this manner. It was 6 by 2, that's 12. 3 by 2, that's 6. 1.5 by 2, that's 3. And then this keeps on going. And of course, we know this is going to be a geometric, because anything related to the radius, if that formed a geometric pattern, this will be a geometric pattern too. So this is 6 over 12, which is going to give us a half. Okay, so now we want the nth term here. So we know that Tn, we need to write the formula. It's AR to the n minus 1. Now we have this answer here. 128 equals A is 12, R is a half to the n minus 1. Now we divide by 12 throughout. What are we going to get? So we've got 3 over 128 divided by 12. I get 1 over 512. So this is 1 over 512 equals a half to the n minus 1. Now the question is, if I see this half as a base, can I express 1 over 512 as a half raised to some exponent? So now I can just focus on 512. Now knowing how to use the calculator is key. Shift, fact, what do we get? Let's just say 512 equal to, then shift, fact, gives me 2 to the exponent 9. Now this makes sense because it means I can say this is a half to the exponent 9 equals a half to the n minus 1. Okay, that's a side calculation. It should not be part of the answers. So if we have same bases, powers with the same bases that are equal, it means the exponents are also equal. So we can say n minus 1 is equal to 9. Therefore, n is equal to 10. Okay, so now we need to write an answer. You can say, therefore, the 10th circle will have a diameter of 3 over 128 centimeters. Try, guys, to be as complete as possible in your answers. I know it's not necessary sometimes, but remember, maths is just a means to an end. It's not an end in itself in certain areas. Here we are applying maths into something a bit more practical. So we need to really answer the question using mathematical means, of course. So how do we score marks? Of course, for answering the question, we get a mark. Now, getting the common ratio is important. And here doing correct substitutions, that's also 3 marks. And we are getting 4 marks here. Now there's too many areas of importance here. This could be a mark because we are using exponential rules. This is also a mark because we are using exponential rules. But since this is all applied, I would mark the first term there. It was not quite obvious, isn't it? So that was a calculation on its own. Rather, we would go for the calculation than the method of getting to the final answer. But like I said, that could be a mark because that's part of the 3-step approach, you know, using a law or exponential laws, and again following that. But then which one do you pick between the two? Hence that 12 becomes a stronger point to mark. Anyway, guys, that was an easy 10 marks. We leave it at that. Well, let's get to the big boys and girls. Functions. As I said, sequences and series must be thought of in a function sense. As you saw my video, I'll still carry on with those lessons. maybe in the coming week if I find time. Of course, I may be inconsistent, but I will try to finish the topic of sequences and series so that at least that is clear. I think functions are easy. They've been taught everywhere else. I don't need to teach that. I have shown how to apply them multiple times. I do believe, even with the videos I have produced so far, if you follow them properly and you practice along, you should not find it difficult to catch up. Then if you do some reading on the side and some extra practicing, it should be okay. But I think the topic of sequences and series sometimes is not really taught properly, usually. And yet the exam can just decide to show an ugly face in this section. Hence I decided to teach it. So I'm only going to teach you guys that and stop at it. Okay, the rest of the topics you should already know, and I think they are taught properly usually. So there's not a need for me to teach those. Okay, now let's deal with these functions quickly. We're given the function f of x equals a to the exponent x minus 1, and we're told a is greater than 0, so obviously it has to be greater than 0. But I think what is more important is to say a is greater than 1, because we don't see any coefficient to a here. Remember, once we see nothing there, it's an invisible 1. So it's 1a, but we never write 1a. A cannot be negative for this to be a function, right? Right, we don't deal with functions like that. So this statement for me is ridiculous. I don't know why they're writing it. It's already not something to worry about. Anyway, let's leave it at that, guys. Sometimes, you know what, these are some of the things that I cry about. That whoever looks at these papers, they don't really examine these papers. They just accept whatever they're given, and then they will claim they did quality assurance. Mistakes have proven that nobody looks at these things, because no two people can miss the same problem. There's no way, unless they're not independent. Yes, if they are dependent on one another, definitely they can, because if the other one is senior to the other is likely to believe it. Or if someone is trusted to the other, they're likely to just believe at face value. But if it is two different people, especially people who are in competition, that look, you guys are doing nonsense, so I'm going to show it, then they are doing this to look for trouble, then we would have a proper quality assurance, believe me. But hey guys, we need to keep such scrutiny to less toxic levels, of course. Anyway, now we're told point B is of this function, so this is very easy. Okay, so not a problem. So what are we going to do? We have 4.1. We are then asked to find the value of a. So this is fine. We know that f of x is equal to a to the x minus 1. Now through point B, with 2 and minus 5 over 9, it will be such that minus 5 over 9 is equal to a squared minus 1. Okay, this implies we then transpose 1 to the other side. So 9 times 1 is 9 minus 5. It's 4 over 9 equals a squared. Now, what guides us here is that this is to the exponent 2, so we can express this as a fraction of 2 over 3 all squared to the a squared. Now, when we have two powers that bear the same exponent and they are equal, it means those bases are also equal. Okay, so that's nice. And of note is that this base, just note, I'm not saying write this down, just note our a is less than 1 but greater than 0. Now when we have that base like that, ideally this should have been a b. A is usually used for the coefficient of that entire power. I don't like it when this is the case, but again, maybe it's just for dynamicity of some sort. But once this is the case, and we know that the coefficient of the entire function was a +1, this already tells us that we have a decreasing function. This is a decreasing function that will appear above the horizontal asymptote. So if we've got something like this, of course, -1 becomes our horizontal asymptote. So our graph is doing stuff like so. Okay. Why do I know it passes through the origin? Well, you find out. You must find out, isn't it? Yeah, man. If you don't find out, who's gonna find out for you? So this is the sketch that comes to mind. Of course, guys, you can think about it. If we're saying for the y-intercept, we make x 0. So this is 1 minus 1. That's gonna be 0, okay? So the x-intercept is at the origin. If we make this 0, we transpose 1 to that side. So for it to be 1, it must have been a to the exponent 0. So that means y is essentially 0 as well. So that's why I know. So you need to be able to look at these expressions by inspection and make a conclusion, guys. Because if you still need to solve for most of these kind of things, then write down the range of this function. And now it's much easier once we think of it graphically, because we can see this function is anywhere above this asymptote. So one can easily write y must be greater than -1, where y is an element of real numbers. For me, this is very important to state. But yeah, whatever, guys, you get 1 mark, even if you wrote y is greater than 1. It's not a problem. One can even do the interval method. It's okay, as long as the set is that of real numbers. If not, please don't do the interval method without qualifying it, okay? Okay, here for substitution, I forgot, we get another mark for the answer, so that's it. Okay, guys, not a problem. So 4.3, we are told to sketch the graph. We've already done it. So a sketch, guys, no need to put this to scale. Okay? No need. Why does it look slanted to me now? I don't like things that are slanted, man. Things must not do that thing. Alright, guys, let's not talk nonsense. I like to do it all the time, so it's like the thing. It's like the thing. Anyway, as it is as, okay, let's say this is -1, 0, x and y. We saw that our graph is a decreasing function passing through the origin. Okay, it's trying to irritate me. Okay, it's not doing what I want. Fine, we have a story there. Alright, guys, so this is what we have, of course. Now we can just label this as f, and we were told to clearly show the intercepts with the axis. That is that one right there at the origin, and any asymptotes, we can see that this is it. Usually some people prefer it labeled. It doesn't really matter then. If we showed where it cuts, it's okay. And I think that's it. So we get a mark for the shape, we get a mark for showing the intercept and the asymptote. That's how we score the 3 marks. Okay, 4.4. Now it is further given that C is a point. Okay, C is the point which has an x value which we don't know, and the y value that is like that. So that is the point C. Okay, maybe let me write it better. we've got point C, which is some x value to 19 over 8. Okay. Now it says determine the coordinates of C prime, the image of C, reflected about this line. So that means the inverse of C. Of course, this demands us to first solve for the x value. So what do we know? We know that our f of x is now 2 over 3 to the exponent x minus 1. Now through this point C, x and 19 over 8, it will be such that 19 over 8 is equal to 2 over 3 to the x minus 1, okay? This implies we transpose the 1 in the 8 by 1, that's 8 plus 19, that's 27, right? 19 plus 8, yep, 27. So this is going to be 27 over 8 is equal to 2 over 3 to the exponent x, okay? In the interest of space here, that's running out for me. I'd like to continue there. Now we can see that this is inverted, isn't it? This is inverted because we've got 2, but 2 would come out here, 3 would come up there. So what are we supposed to do to get this right? Well, there's many ways, guys, of dealing with this issue. There's many ways of dealing with this issue, but I think to apply logs, it's a logical step for a matriculant, because other means might be a bit naughty. I mean, there's many ways, honestly, to deal with this, because this is 3 over 2 all squared, and that's the case over there. So let's just leave it at that and say, fine, we introduce logs. So this means log of 27 over 8 is equal to the log of 3 over 2 to the x. You can say this implies that our x, now I'm going to use the log rule fast and furious. Now this is going to be log of 27 over 8. The base is going to be 3 over 2. Why did I have 3 over 2 now? Yes. It's wrong now. It's wrong. So this is 2 over 3. Okay. Not a problem. So here we can just use the calculator and say therefore x is this point right here. Now we've got log to the base 2 over 3 of the number 27 over 8. We don't want to complicate our lives here. So what do we get? We get minus 3. So this is minus 3. We can say therefore point C is the point minus 3 is 219 over 8. We can say therefore C prime, we reverse this. This is going to be 19 over 8 is 2 minus 3. Done. Okay, that was a bit long for 3 marks, but hey, who cares? As long as the math is done right, everything is perfect. So where are these marks? Of course, guys, the marks here are essentially in the substitution here, and finally getting that answer and doing the inverse. So that was an easy 9 marks of this question. So this one was very easy. They kept it to the standards. Okay, nothing complicated. Let's get to question 5. So question 5 says, sketched below is the graph of f. Now this is a hypothetical equation. Okay, we need to find some things in there. Having this domain, again, this just means x is an element of all real numbers, but x is not equal to 1. This is the best way, but this notation is still fine. Now it says the graph of f cuts the y-axis at, so this is the y-intercept. These are things to notice. Okay, and we can see that point is shown there. A line of symmetry of f is given by, nice, and we can see this is the one with the positive gradient, and this is this. And where does it pass? At the center. The center is where the asymptotes meet. It is the center of the hyperbola. Please remember that. So that's not a problem. And now we can clearly see that the vertical asymptote from just inspecting this graph is cutting at 1. So that means our equation is going to be f of x equals a over, now this is going to be x. If this is positive, it must be negative in the function, plus q. So this is exactly how this transforms. So we needed to find that value there. Okay, not a problem. So what else can we do? We can see that this very same y, we can plug 1 in there and solve for y. So when we plug 1 in there, we get 1 minus 3, that's minus 2. So we have the coordinates. It's going to be 1 and minus 2. Maybe it's not clear. So can you see this equation? If we plug 1, because it falls right on this point, which is a point on this line, so we can substitute that 1 and get the corresponding y value. Again, we are being given the coordinates of this center indirectly. Now we can go back and say, now this refines our graph, our equation to be like that, because remember now the minus 2 is the horizontal asymptote. So all is left now is to find a. Okay, so can you see, guys, if you work on your graph with some understanding, everything else becomes easy. So let's see, 5.1 says write down the value of p. P is minus 1, okay? We get a mark. 5.2, determine the equation of the horizontal asymptote. So this is easy. This is 2 marks, and the question says determine. Now a determination is sometimes by inspection or whatever, but here there's no guessing that minus 2. We really have to perform. So we can say, well, we know that g of x is equal to x minus 3. So we can say essentially what would be this implies that g of 1 is going to be 1 minus 3. Therefore g of 1 is going to be minus 2. We can say therefore the horizontal asymptote is such that y is equal to minus 2. So guys, whatever you do, try to present your answers in a way that makes sense. Of course, no one is going to ask you, why did you put this? We can see it. It's there on the graph. So what matters is getting this and writing the equation. Very important, okay? Not a problem there. So we have 5.3. We need to calculate the value of a, so we know that f is going to be a over x minus 1 minus 2. Now through the y-intercept that was given to us, we can see that 1 is going to be a over 0 minus 1 minus 2. this is going to imply, we transpose this, we get 3 is equal to minus a. Therefore, a is minus 3. Again, does it make sense? Yes, because this graph is in the second quadrant and fourth quadrants. This is only when a is less than 0. So this is good. So now, what was the question value of a? So we are done. Okay, guys, so what matters is writing this equation here. This is very important. The substitution and the answer. So make a habit of always not forgetting these important steps in solving a problem. The 3-step approach will never teach you. Any other means will leave you short most of the time. Anyway, for which values of x is our graph above or equal to 0? So if we follow this graph from the left to right, remember whenever this question is asked, always scan or read the graph from the left to right. Don't be haphazard, because that way you will avoid problems. If you have a ruler, you just place your ruler and then you read. Can you see? If we read this graph, it's climbing. It's 0 there. So this means we need to find that x-intercept. And above this, it's positive, and that's exactly what we want. We want it to be positive or 0. So can you see? This is this portion of our graph that we want. Now, this is limited by the asymptote. So this already suggests that this is the interval where this is not included because the graph is not defined, but that would be included. But that is the interval that we want. Okay, good. So we can see that our task is to find the x-intercept. So we can say f of x equals minus 3 over x minus 1 minus 2. For x-intercept, it is such that 0 is equal to minus 3 over x minus 1 minus 2. This would imply we transpose the 2, there we get 2 equals minus 3 over x minus 1. That we divide by 2. Our gymnastic of choice, cross multiplication, this implies that we get 2x minus 2 equals minus 3, and therefore x is going to be, we transpose this, we get minus 1 divided by 2 is minus 1/2. So can you see, that is where the x-intercept is. All right. Now, at this point, we were not interested, but we can say, well, the x-intercept is minus 1/2 and 0. We can say, therefore, to answer this question now, x must be less than 1 because it can't be included, but greater than minus 1/2. Okay? Now, that's it. But now if we scan further, we jump the asymptote. Now, this is a jump. We start again. We move to the right. We can see that this graph is negative. It's not above the x-axis. So it's out. So this answers the question. So this is another way of asking someone for the x-intercepts indirectly. Some examiners are naughty. They can ask questions in a smart way, force you to do some calculations without telling you to. All right, guys, so this is important, especially that substitution of 0, and essentially finding this x-intercept, and of course the final answer. So that's it. But again, one may get 2 marks for the answer and 1 mark for finding that, because that is already implied once we speak of x-intercept. So it depends on really what the marking guidelines are going to suggest. All right, so 5.5. It's a 2-mark question. Maybe we can squeeze it up there. So the question says, the graph undergoes a transformation. Now, guys, we've been speaking about this. You can't get to any math exam and you don't know about transformations of functions on the Cartesian plane. If that is not on point, please kill yourself, because this is one of those higher grade questions, which is not really that difficult. It just picks your brain a bit. Okay, f undergoes a transformation to h, okay? Now the domain and range of h are the same as that of f. Now, what would make the same thing? Let's think of transformations that can do that. If we look, what is the domain? The domain was that x is an element of real numbers but must not be equal to 1. That's the domain. And what about the range? The range here would be y values such that y is an element of all real numbers, but y should not be equal to -2, right? Because the graph is not defined there either. So we are saying these things must be kept. Now, if we do a reflection about this line, the axis of symmetry there, we do what we call an inverse here. What happens is this comes to lie there, that comes to lie here. So literally this function has not changed. Now we can't really call that a transformation. So doing an inverse for the hyperbola is not helping, it seems. Okay, or at least reflecting about this line. But this is an inverse line because these are the axes basically. These asymptotes are the axes that have shifted. So this becomes nothing but an inverse, because once the gradient is 1, that angle is 45. So that is the line equals to, y equals x essentially, but has shifted, suggested by the y-intercept there. So an inverse doesn't change this function, so we can't call that a transformation. So that is eliminated. But now let's do a horizontal reflection. But remember, since this has been shifted, now we need to reflect it about these asymptote lines. Now let's say we do a horizontal reflection about the line x is equal to 1, right? So if we fold this forward like that, what is going to happen? We will see our graph doing stuff like that, right? And then as we do so, this one is going to do the same. It's going to fold to somewhere here. It's going to fold to somewhere here. Okay, not a problem. Now, can we see the domain remains the same and the range remains the same, but this is a different graph now, because this is in the first quadrant, this is in the third quadrant. Now the characteristic of A has changed from being negative to positive. Okay, that's a possible transformation. Now it says what? H of x, the derivative of h, is negative on its domain. Now I don't know what this is. What do they mean on its domain? Was this statement necessary? In my opinion, it was not necessary. Again, another failure by the quality assurer. If we already said that domain and range of h is the same as f, we are saying now that derivative is negative. That would have been perfect. This on its domain for me is ridiculous, because it's just trying to confuse unnecessarily. There's no need for that statement. Of course, we can see that if we drew tangents here, just do one tangent. Can you see these are all positive tangents? So when A is negative, the graph will always have positive tangents, meaning positive gradients. But when A is negative, we can see that the tangents are negative. And if the tangents are negative, it means the gradients are negative. And the first derivative talks about gradients. Again, this we've been speaking about multiple times from trigonometry, you name it. That when we talk about the derivative, always think gradient. Okay? Because sometimes this is exactly how we answer this. And we can see that definitely this transformation of doing a horizontal reflection here works. Now it says, describe a possible transformation that F could have undergone to result in H. So here we can just write 5.5. We can say F is horizontally reflected about X is equal to 1. Okay? Or we can say F is reflected about the line X equals 1. But that's a horizontal reflection. But remember, sometimes, the one thing that would protect you here is that when you say horizontal reflection, you are talking about the y-axis. Usually, that's what we talk about. So, now specifying the line is more important in my opinion, to show that this is still a horizontal reflection. But again, if you just said it's reflected about this line X, I mean, if we are reflecting a graph about a vertical line, that means it's a horizontal reflection. It's from left to right and vice versa. So I don't think this is an important statement to mention. We can say, maybe let's write it better, because that only provides for a horizontal reflection. So I can say F is reflected. Sometimes my writing, I don't know. About the line X is equal to 1 to obtain H. Okay, so that's it. That's what we can say, because a vertical line provides for a horizontal reflection, and a horizontal line provides for a vertical reflection. So we just leave it at that. Okay, so that's it, guys. So the fact that this is a reflection gives us a mark, and the specific line gives us the second mark. Okay, now that's a very easy 10 marks. So guys, if you've been really following my videos and how we discuss these things, even I'm a cry nice, isn't it? Even I'm a cry nice, guys. I don't see any struggles for anyone so far. Maybe the only question that could have picked your brain would be this, if you were not prepared. But if you've been following most of the videos I have done since 2021 up to now, I mean up until you guys were writing the exams, there shouldn't have been a problem. Of course, not just watching me do the work, but getting involved, getting your hands dirty yourself. Okay, here's one of the tough ones. Usually a parabola can be a problem, because it's so well understood. So many tough questions can be made to come out there. Okay, so let's have a look. Question 6, we are given a diagram which is the graph of f parabola, and we can see that the coefficient of the highest power there is negative, and that is a grumpy face parabola. We are happy about it. Y-intercept is at 5, and you can see it's indicated, and G, a straight line are drawn, but we can see that they share a common x-intercept, which is good, and we have an extra point on both the graphs. Okay, they intersect there, and that point is given. Okay, C with coordinates 3 and 8 is a point of intersection of F and G. EH is drawn parallel. Now, if it is drawn parallel to the y-axis, what do we know? What do we know? We know that this is a vertical line. So it means if we write the coordinates, so x at h and some y value at h. At E, we can see that this is still going to be the x at h and the y at E. So guys, these things are very important to appreciate, is that a vertical line has the same x value for different y values. That's key. With E a point on F, okay, and H on G, great. Now, what is this B? See, we need to look at this whole thing nicely. And we can appreciate A and D are x-intercepts of the parabola. That looks like a turning point, but we need to find out. We can't assume. We can't assume. Even that D, okay, it looks okay to see that, but no one said anything about it. Now it says calculate the coordinates of B, the turning point. Can you see? That is the most important. Okay guys, so for me, for 3 marks, the best thing for me is just to complete the square, get my coordinates together nicely. Of course, there's many ways of skinning this cat. So 6.1, I know that my f is equal to minus x squared plus 4x plus 5. This is the same as minus into x squared minus 4x minus 5, right? Which is the same as minus into, we take these ones, we half that, and then we square. Then we say minus 5, and we immediately take half of that squared. All right, okay. So this is going to be minus into, then we deal with this. This is going to be minus 4 minus 5, that becomes minus 9. Then we redistribute, the negative is going to be minus into x minus 2 plus 9. We can say therefore B is the point 2. We take the opposite sign, and that we write as is. So for me, I trust completing the square. Of course, guys, even if you didn't show us this, usually this is regarded as not examinable, but writing it in vertex form is a mark, okay? And those 2 coordinates. That's it. Of course, you can do any other means necessary. There's many ways of dealing with that. With an equation, a grade 12 student is limitless as to what they want to do there. So I'm not going to bother. 6.2, we need to show that the equation of the line through A and C is given by that formula. Okay, that's not a big deal, because here we just need the coordinates of A, right? Right, because once we get the coordinates of A, but why is this thing 3 marks? Why is this thing 3 marks? I'm a bit unhappy now, because I cannot be getting 3 marks for that. I need the coordinates of A, that's work. And then find the gradient, that's work. Find the y-intercept, that's work. So 3 marks. What am I missing? Is there anything I am missing? Anyway, looks like there's nothing, so the examiner here became a bit stingy. I don't get it. But let's go on. We don't really have a problem. We can say A is such that 0 is equal to minus x squared plus 4x plus 5, which implies that 0 is equal to, we can factorize this thing. Usually it's going to be minus x. We've had minus 5 minus 1. Let's see. So this is going to be, yeah, it makes sense. It makes sense. So I think this is it. We can say therefore x at A is going to be minus 1, right? When we solve that bracket, we don't really care about it. Okay, we can even write x at D is going to be 5. We can say therefore A, because we're interested in A now, is like so. Here the reason for this is the x-intercept. Okay, although this was not stated clearly, but we can see it. There's no question about it. So now what are we looking for? We can say then we know that the gradient of AC is going to be y at C minus y at A divided by x at C minus x at A. This question was crazy. This is 8 minus 0 divided by 3 minus 1. So this is 2, okay? Not a problem. You can say therefore, so this implies that AC is the line y equals 2x plus C. We can put any value there. C, which is 3 and 8. We're going to have 8 is going to be 2 into 3 plus C. Therefore, C is going to be 2. Therefore, y is equal to 2x plus 2. I'm still thinking, so much work for 3 marks. Lord. Anyway, guys, that for me should be a mark, and that for me should be a mark, and the substitution there is what matters. Of course, we can either say substitution or the C value because it was not quite obvious, and the rest was volunteered, so it doesn't really matter. We've got the 3 marks, but what about factorizations? You see, this is why I'm feeling like this question, unless I'm missing something, but it's not a big deal. If we answered the question, we are happy. Now let's look at 6.3. 6.3 says we need to calculate the maximum length of EH for F greater than G. Now, that means F must be above G, and this is the case here. Okay, so over that interval, AC, this is when F has bigger Y values than G. So this is what we want. So basically, that is what we're talking about. Now, for that to be a maximum is the parabola minus the straight line graph. So this is easy. We're going to need calculus here, but I think grade 11s can do it too. So let's see. we know that EH is literally going to be y at E minus y at H, the bigger one. Now y at E is the parabola, so this is minus x squared plus 4x minus into 2x plus 2. We simplify. Minus x squared plus 4x plus 5 minus 2x minus 2. This is minus x squared plus 2x plus 3. Now folks, if we want the maximum value, there's many ways of doing this. Again, I can easily just complete the square, because with that I can take the maximum value that I would get. So this is more like finding the turning point of this thing, and that would become the maximum value. So I can still continue, just complete the square here. I get x squared minus 2x minus 3. Maybe let's put big brackets. So we take these two, we have that, we square, we immediately subtract that minus 2 halved. So that one is going to be like that. We simplify further. This is going to be minus 4. Right? Right. And then what do we get? We redistribute this, it becomes minus x minus 1 all squared plus 4. Now, remember, when we're looking at an algebraic expression in simplified format, we think about it. What we're saying here, maximum. Remember, this is a perfect square. Now, a perfect square can either be positive or 0. Right? So it can either be 0 or positive. No? But now here's the thing. We want the maximum length. Alright? Maximum length. So what are we going to say here? We will say if this is 0 or more than 0. Right? Right. But because this thing is dragging a negative, now the issue here becomes that negative that is being dragged. So this means, well, if this is 0, then that's it. That's the biggest this value can be, right? Because if this thing is positive, let's say it's 20, it's going to be minus 20. Minus 20 is way less than 0. So the biggest this thing can be is 0, right? So this means the maximum is going to be 4. So we can say again, Google, therefore, EH max is equal to 4 units. Of course, guys, I know I confused you here deliberately. Now, I'm just trying to accommodate those who are from grade 11. They're still not, the people who did calculus. Some students from this step, after we get our quadratic, they know that the maximum is the value at the turning point. They could have chosen this route and said, okay, I want the y value at the turning point, so I can say EH max. Maybe let me write it like so. Someone can say EH max is going to be 4ac minus b squared over 4a. Right? Because I just want the y value at the turning point. So this is 4. A is minus 1. C is 3. Minus into 2. Okay, it looks like I'm squashing myself here unduly. Okay, maske sizama ukubhala kakuhlana nje. So one could have said EH is going to be equal to 4AC minus B squared all over 4A. This is going to be 4 into minus 1 into 3 minus into 2 squared, all divided by 4 into minus 1. So this is going to be minus 12, right? Minus 12 minus 4, that's minus 12 minus 4, that's minus 16. Minus 16 divided by minus 4, that's 4. So this is it. So this could be another way of doing this from grade 11. Just know that max means the highest, and the highest would be the turning point, because this is a negative parabola or a grumpy face parabola. Or a grade 12 who is repeating now, or was writing at the end of the year, they could have said, well, EH max is such that, or should we say dy implies, maybe we can say that EH Emax implies that EH dH over dx, is it dx? Yeah, must be equal to 0. So we take the difference, we differentiate this expression. So we use the power rule there, we get minus 2x plus 2 is equal to 0. And then we go on and solve for x here. We know that x is going to be 1, right? So transpose that, divide by minus 2, we get 1. We can say, therefore, EH I don't know what I'm doing now. Is going to be, we take that original expression, now we're going to put 1 where x is. Put 1 there. And then what do we get? This is minus 1 plus 5. This is 4 units. Alright, so there's many ways of killing this cat, but kill it. But now we can see that if we differentiate, it wants us to find the x value at the turning point. Another student could have chosen to just say x is equal to minus b over 2a and solve for x and get this first, and then substitute into the original equation for this distance as we found above, and then we sort it out. So this is not a big deal. So that's it guys. So there's many ways of killing this one. As you can see, just try to choose the most direct approach and to avoid problems. They are not necessary. Okay, so how many marks are we scoring here? Of course, getting this expression is key. Sometimes I don't know what happens to my writing. It just loves to mess with me. And of course, writing in vertex form is a mark for me. And then scooping up, this one is the third mark. We are getting 4 marks. Heban. How do we get these now? What is that? I mean, what we did here, okay, maybe this expression is okay. We can get a mark, or maybe those 2 marks and then substitution here and then answer. That is where the other 2 marks come from. Or when we do the differentiation here and we get another mark for equating this to 0. I mean, I think the differentiation is more important, and perhaps the x value here, then substituting here and the answer. So this is essentially how I believe these 4 marks could be scored in those different techniques. But this step right here, up until here, is the main. Without it, nothing makes any sense. We would not be able to choose what we can do. Okay, not a big deal, guys. Let's not waste time. 6.3, no, 6.4. Now we're told K is F shifted horizontally, right? And this is now expanded here nicely. And we're told now to determine the value of M such that G is a tangent to K. This is one of those higher grade questions. Again, there's nothing to this question, guys. These higher order questions are just questions that seek to push you around a bit. Now remember, if we are shifting this graph horizontally, we can either shift it to the left or to the right. Now let me demonstrate to you what this would mean. Let's just get this graph nicely. Of course, guys, it's not going to be a perfect match. Doch. Iyantlwaela jwale. Ne ke sa e batle ka tsela ena e re ke etse hape he. Hobane jwale e se e ntenne jwale. E nketsa diphahlo jwale ya ntena ntweng. E ntlaela hampe. Now let's do this. Now, when we're shifting it horizontally, this means we can shift it this way. But you see, when we shift it this way, we will never get it to be a tangent. So we can't shift it to the left. We have to shift it to the right. Because when we do, when point C can become a tangent. At this point, we don't really care whether it's C or not C, the point of tangency. But you can already appreciate that if we shift it that way, then we start to have a situation where we have a tangent. Because even if this is the point of tangency or not, we really don't care. Okay? But all we know is that this graph must shift to the right. Okay? And as we have shown here, that when we do it, we can almost demonstrate that this becomes a tangent because this is a horizontal shift. Again, we need to appreciate this in notation form so that we can just see what to do about it. Now, folks, there's nothing that defeats anything here. What matters here is differentiation. Now, we know the gradient here is 2. And if this G becomes the gradient, the tangent to K, it means they must have an equal gradient, okay, at the point of tangency. So, well, this is very easy, guys. And what I love is that they could have left this part for you to sweat in finding it. But now the examiner was very friendly. He expanded, or she expanded it for us so that we don't have to do this exercise. We should have been doing it so that we can suffer a bit. But the examiner was a bit friendlier, made our lives a bit easier. But now this is not in standard form. We need to write that in standard form. So now let's talk. We are going to say K of x is, of course, the highest power comes first. It's going to be x squared. The next is what has the x terms. So now this means we need to group this and that together. So now we can decide, okay, let's start by saying 4x minus 2mx. Not a problem. We can do that. And then, but now I want to quickly sort this out. The highest common factor here is 2x. Okay, is 2x. But I'm not interested in taking 2 out. I just want x out. So what I'm going to do, I will remove the x here and here, and then group these together like that and put my x in there. This is the best way to showcase this nicely. So I would have 4 minus 2m, and then I'm pulling x to the side. So I don't need to manipulate the signs at all. I leave that as positive nicely, because it doesn't change that expression at all. And then we then deal with the constants. Remember, m is a constant. That's another thing we need to appreciate. M is a constant, meaning it's just a number. Okay, so we can bunch m squared with 5 and 4m. So we will have plus 5 plus 4m minus m squared. This whole shenanigan is c. Okay? And this whole shenanigan right here is going to be b. And guess what? This one is a. So now this is in standard form. Ax squared plus bx plus c. So being organized is very important, guys. Again, here mistakes are likely to occur because there's a whole lot of things to think about. But how you organize your work makes it easier to handle. So it's all about who is doing what. Now, we are saying at point of tangency, here we can write and g of x is equal to at point of tangency, it is such that the gradient of g is equal to the gradient of k. Right? We're going to use that property. Not that they are equal. We could use it if we needed to solve for this thing, but now we can see that m here becomes the only variable when we eliminate x. So our lives are going to be a bit better. You get it? Yeah. Okay, now let's think about it before I start messing up. Is it going to work? Okay, it looks like it will, but I feel like I will still have x, which I don't want. I really don't want x, but it doesn't matter anyway. We will see. Now it looks like that c becomes the point of tangency. I think that c becomes very important, but we cannot claim, or what can I say? We cannot claim that it is so. We have to prove it to be so, you know. Yeah, now I'm thinking about it a bit, but let's go for it. Let's differentiate here. We know that the gradient of g is 2. This is going to be equal to, when we differentiate here, we get minus 2x, right? And then this disappears. We'll get plus 4 minus 2m. Now this is an entire constant, so when we take the derivative here, it becomes 0. So this is out. But now we still have x. That's just the issue now. So, well, it doesn't really matter. We can leave this one like so. We can leave this one like so. But I think if we express x in terms of m, it will solve our pain. So this implies, now let's solve for x here. So we know that 2x is going to be equal to 4 minus 2, that's just going to be 2 minus 2m. And therefore it means x is going to be equal to 1 when we divide by 2 minus m. That that would be the value of x. Ne? So we can make this one equation 1. I think here the concept of simultaneous equations is not going to escape us. It's not going to escape us. So we know also, maybe I should have done this question on a new page. It's too long. I don't like this broken fashion. That's starting to annoy me. Right now, okay, so this is what we can do. I thought we can avoid a second equation, but we can't. Now, we know also that at the point of tangency, also these two graphs are equal because they share the same x and y value. Right? Right. So now we can just decide I am thinking, since we know what x is, okay, all right, wait a minute. Why is this question trying to flirt with me now? Can't be flirting with this kind of thing. Okay, now let's think about it again. At the point of tangency, we know that g of x is equal to k of x, right? Yes. This implies that 2x plus 2 is equal to what we just wrote over there, minus x squared plus 4 minus 2m into x plus 5 plus 4m minus m squared. But now we know what x is. This implies, now I'm moving fast. In fact, let me not even name this anything. Remember, this x is still the same x as that x in the point of tangency. So where we see x, we put that. So we've got 2 into 1 minus m plus 2 is going to be minus into 1 minus m squared plus now this one is annoying, isn't it? Yeah, this one is a tedious one. This is what I meant by some naughty things here, because yeah, now here mistakes are bound to happen, but we will see. Now we fold this out, we get 2 minus 2m plus 2. We get here minus into, we can fold this out, it's going to be 1 minus 2m plus m squared. And then we deal with this one. Plus, when we do this, we'll get 1 by 4 is going to be 4. Right? And then this is minus 4m. Okay, let's just go about it nicely. This is going to be, this is that 4. This is minus 4m. Minus 2m is going to be minus 6m. And then this one is going to be plus 2m squared. Yep. Plus 5 plus 4m minus m squared. Now there's going to be some issues here for sure. Okay, let's handle it nicely. So we've got 2 plus 2, this is 4 minus 2m equals, break this up, it's going to be 1 plus 2m minus m squared plus 4 minus 6m plus 2m squared plus 5 plus 4m. minus m squared. Okay, looks like I'm in trouble now. I'm telling you. Of course, minus m squared, this is minus 2m squared, and then plus 2m squared, that's 0. So those are out. They take each other off. Okay, we're getting somewhere. And of course, 4 being the same on either side of the equation is bye-bye. Right. Now, what we are left with is minus 2m plus 2m. So that's, okay, let's start with this side. 4m minus 6m, that's minus 2m. So this and that, they take each other out. Okay, so there's a lot of cancellations here. Now what we are left with is minus 2m is equal to, so we've got minus 1 plus 5, that's 4. So we've got 4. So therefore, m is equal to minus 2. Yo, that was a hot potato. Awukwazi ukuvala umlomo xa usitya phayana, so isiqhela kakubi kahle. So isiqhele kakubi. Now let's look at this. If m is minus 2, guess what? What is the x value? X is minus into minus 2. That's 1 plus 2, that's 3. So that is exactly that point of tangency right there. And if this ties up nicely, and I mean, I just did nothing. I shifted the graph horizontally. And if this thing ties up, I know however complex this mess was, if it gives me something as realistic as what I see, yes, I may be misled here, but for me, it feels like at the point of tangency, they must have the same x value, and that x value is what seems to be the case, so I'm happy. So as I said, examiners, guys, will always provide a way of one checking if their answer is making any sense at all. But again, it depends on how sharp you are and how good you are with your work. As you can see, some questions will cause you to sweat because they get a bit complex. But being comfortable with these algebraic expressions from grade 10, because in grade 10 you do a lot of these hectic things so that you can learn to concentrate. And then they become removed from grade 11 because now you start to learn about parabolas and stuff so that you can master them uninterrupted. Now in grade 12, it can be brought up when you least expect it. So meaning your algebra has to be strong. And this emphasizes the point we made above, that indeed we need to be very good. So can you see at the point of tangency, we saw two things. That these must have the same gradients, indeed. And they also have the same y values, indeed. So this is good. This is good. Because once you solve for the x value, now we know that this is 3. And if we put 3 in there, what do we get? 8, the corresponding y value. So this is indeed that point C. Okay, guys, I hope you've enjoyed this one. This one was nice. This one was the one that can make you think about it and cry if you want. So anyway, guys, I still believe this is mark worthy. And doing the actual differentiation here is sometimes mark worthy. I don't know if I can give the entire thing 1 mark or the whole thing just 2 marks, whatever. And of course, equating these two is a key step in our process. And essentially, the rest of this gymnastics now no longer matter. What matters is the answer. So we've got 1, 2, 3, 4. So we can indeed for these two. But I mean, we can decide here that technically the differentiation and the entire setup, or maybe left hand side, right hand side, it doesn't really matter, guys. 5 marks are in the bag. And as you can see, as complex as it was, it still provided us a way of checking if we are losing the plot or we are not. As we said, the graph may not be drawn to scale, but certain issues will tell us what we are dealing with. Okay, guys, I hope that one was nice. Now let's get to the financials. I'm sure some of you cried when you got to 7.3. That's what most students have been crying about. Of course, I did highlight what was the way to deal with this problem. Maybe some of you have already done it and solved the problem. I've seen some memos have been done already by some very early birds to catch those views and those likes. It's not a problem. Now let's confirm or disprove what they did. Who said I'm correct? Well, it's an assumption, is it not? It's nice to assume that you know when you don't, because then it gives you the fighting spirit. Otherwise, if you already give up before you even try, how will you get the courage to keep bouncing back even when it goes wrong? You know, sometimes you need a bit of an ego in life, because it's what keeps you moving, you know. As much as people can talk down on that and try to tear you apart because of it, nah, man, it's just what it is, you know. You know, I've been following this case of the judge, the JP, the judge president of the EC. Is it of the EC or what? Yeah, whatever. You know, the issues of relationships at work, it's technical, you know. Here is what I know. It doesn't matter what the books say or the law says, okay? The law has its own way of talking nonsense, of becoming impractical. It doesn't matter how nice it sounds. And perhaps for the greater good, yeah. But here's what I can tell you guys. You tend to be attracted by those you're surrounded by. You know why? Because you know them. That's the thing. You know their behaviors. You know their attitudes. You can almost approximate how they are in general, because you see them all the time. So you know where you can be safe. Get it? So it's easy to fall in love with someone you work with, a co-worker, than you would a stranger, because you don't know what trouble you'll be getting yourself into. It's even more difficult when you are a high-profile individual, for example, like the JP. Of course, somebody knows you have money. Now imagine the JP trying to jol with someone who has time on their hands, and he doesn't. He spends most of his time in court every week, you know, dealing with matters. Now, where does he have time to spend with someone who's going to want quality time, who's not as busy as he is? So he's likely to have a GF right where he works. Doesn't matter how you look at it. Come on, guys. Look, it's easy, Moss. If someone doesn't want you, they will tell you, no, man, I'm not interested. Or I have somebody. Or at least I think it's inappropriate, when they feel this is going to overpower them. Because obviously, if I'm your boss and I say a lot of things, and most of what you can do will have to pass through me, you may be intimidated into accepting this, even if you don't want to. But remember, guys, this is South Africa in the what century? I don't know. We're in the 2000s now. So I don't know. Is it 21st century or whatever you call it? Let's just say it's 2025. I mean, guys, come on. You can't tell me there's no woman who knows who doesn't know their rights, because if anybody tries to abuse those, it's so easy to tip them over. Gone are the days where people can be intimidated and what. You get it? So the nonsense of saying, power struggle, I mean, come on, man, it's immaterial. If you're not interested, you just humbly ask someone to just leave you alone. It's as simple as that. Of course, I'm a man. I will always persist, because remember, if I chose you, it's because I've made up my mind about you. So for me as a man to lose out like that, I mean, we are hunters by nature. I'm not excusing anything, of course, but we are hunters by nature, guys. We will always persist where we see value. In fact, our persistence already tells you that we scored you high in our books. And so it's not so easy to just give up. But someone who was just passing through and trying to score, puff a smoke there and just that's it. Of course, if you just jump around, they leave you alone because they were not interested in you. In fact, here's the one difficult thing. If you're a guy, you approach a girl, I'm going to put it that way because I'm talking to children mostly, although there may be adults here. Or let's just say a man approaches a woman. Me, I'm that type. If I show interest in you and then you jump around, even if you're playing hard to get, I'm gone, okay? It's because of shit like this where if you persist as a man and then they'll say you're abusing your power, this and that, because obviously there's going to be communications with me trying to really argue my case until I win. I mean, as a man, it's your job to do that. You fight to the death, isn't it? Unfortunately, sometimes when it goes wrong, it is interpreted as being immoral, and that has nothing to do with morality. And you are looked at as somebody who is unethical. It has nothing to do with ethics. This is interpersonal relations. They do not have rules. There's no manuals for these guys. And of course, he has a wife and children, but does he spend time with them? No. That's why he ends up looking around where he is. Because where does he have the time? By the time he's at home, he's tired. He wants to rest. He's been punched with thinking, cracking his skull, trying to decide a case and trying to be fair, reading, guiding, moving, even if he goes back to his wife. I mean, there's not much he can do there. He's not going to have, the normal relationship until he retires. When he does, he's going to be too old to even be a useful partner. Even that wife is probably cheating on that man anyway. And let's face it, it's just natural, man. If someone is not given the attention that they deserve, they always look around. It's just that they have not been caught as yet. Or maybe there's no possibility of being caught. Who knows if any of his children are actually his? No one knows, because if you look at his life, he's probably been away from home as often as possible. Hey guys, let's not talk about the case. In fact, what was I trying to say? I don't know now what point I was trying to make. Now I got carried away. Goodness. But in any case, guys, all I'm trying to say is, I'm gonna nzobaxhasa mna shem. Okolleague bam ndiyabaxhasa. I do not care ukuthi or a junior or a senior position ndiyaxhasa qha. If ndiyayincanywa iway ndiyayincanywa qha. Xhasile lo way leyo. Qha nansi into endiyenzayo ke mna ke guys. If you were yatsibatsiba, because vele it's already a sensitive place to try such things. Unfortunately, this is where we are anyway. We hardly are out there. If we are out there, we are vulnerable to vultures. We're just looking for what you have rather than who you are. So these ones, they already know you, so they have no fear of anything about you. So they also have something of their own, by the way. So you're not really on a power struggle here. It's more like, trying your luck whenever you can. Mna ke xa ngichasile yatsibatsibi way andisacengi ke mna andisabuyelanga lapho. In fact ke indalo ke mna zange ndakwazi ukucenga ke guys, unfortunately. So that is something that God put in me, maybe deliberately, knowing I'm gonna be probably someone to be subjected to these kinds of nonsenses. Because girl, I cannot hide the fact that I'm naughty. And as naughty as I am, I love women. I never know, guys. No singathi abantu. What you say? Ngathini? I would rather die. Unoba ndingathanda amanina. Isikete ndiyazithanda. Futhi ke mna ke ndithanda isikete ke, like, the proper skates, like real skates, I'm sure you understand what I mean. Yo guys, ndithetha strong language now. This is adult stuff. If you're a child, close your ears, just for a minute. But if you are not a child, I mean, at the end of the day, if you are doing maths in metric, you're already someone who's 18 and around that age. So this is no news to you. Mna ndizithandela ezilokhweni bafethu, hayi noba ningathini, and ndizithanda okokuphambeneyo. Kodwa ke andisosibhanqa. That's the one thing I can say. But hey, tomorrow, who knows, I might be accused. Hey, ngixhase intern lapha nesibani. Indoda ezinye interns phela zindala, they are not children. Uyafumana? Ezinye interns sezikhulile ngabantu abekhe benza ii-degrees somewhere. Manje uzobuya nandibona into eqhafuqhafu bandiqomba emfethu ndiyayishaya le. Like, not necessarily in a bad way, like weyam le ndiyayincanywa le. Mna ke ndiyangoba ndimncanye umntu, not necessarily uba ndimrhalela into ezokurhalela abantu andinazo. Andinaso futhi neso sikhathi, because that's ridiculous. It's dirty, it's ugly, man. It's already bad. Funeka omnye umntu umnike respect. If awumthandi hlukane naye, right? Because akho ukuthi hayi benifuna nje udlulisa. Awukwazi udlulisa ngomntana omntu. That's a human being, one feelings, and yena angeke ayiride ngale ndlela oza ngayo. That means you're destroying a life, you're destroying a spirit. No, you have to be on the same page. Ndiyakuncanywa, but apho sekufike sahlukana khona, because as you go along in life sometimes, you start to realize that this is not what I signed up for. I thought I was saying something, but this is not it. So you walk away. And of course, that can still be interpreted as, sometimes it's not about that. Because remember, persons like me, let me put myself on the spot. In a woman, you like someone who can, at an intellectual level, match you. They don't have to be a doctor, like I am a doctor. They don't have to be something higher than that. No. Even someone who didn't go to school, if at an intellectual level, siyamatch, ayunqibile. Because that's the one thing I hate, to always explain myself. And andimfuna umuntu insecure, guys. Zabe kufuneka ngoxa inibone nime no beauty laphana, sangathi siyahaga sidle lunch. Sebeyinyakanyaka eninzi ke ngoku uzafaka yonke inyakanyaka, because nama andinaxesha loba ndibona omnye isikhoko laphana. If I don't catch the vibes zoba kuyajolwa, andinankinga. But even if sendizikhethe ezo vibes zoba kuyajolwa laphana, if I catch the vibes, I am out the window, okay? If not through the door that I entered in. So I don't attach bafethu. It's not that easy, it's not nice, but look, mntu makekubhayizisa, walk away. Don't fight, don't argue, don't kill. There's no need. Those people don't define you anyway. You found them alive and well. So you were well and alive yourself. It's just that now they became a part of your life. Of course, it's not going to be easy to lose them. But to kill, because now I've given, look, if I give you money, it's because I want to, okay? If I buy you something nice, it's because I want to. I will never do it because I have to. No, if I don't have money, I'm not buying anything. If I have money and I feel like doing it, I will do it. I can even buy you a car and a house. And then I will not come back and say, I want my house back, want my car back, so that come on, it sounds like it's ridiculous, but that's how I operate, guys. I don't do things for people that I will regret doing. So men, get it right, folks. Don't do things for people expecting that they will be loyal to you. Do things for people that you want to do for them. Do things for people that you can do without suffering. So that when things don't go well together, you can just go apart without causing any problems. Of course, things like a marriage, it's a contract on both sides, so things get split. It's a must, okay? But emjolweni akhonto even a contract laphana, so uyofuna into zakho uzoxhomekeka ukuthi yakunika. If yakunika akunike, if akafuni, there's no need to fight and kill, okay? Because at the end of the day, be informal ke leyo into. Anyway, guys, bensaphefumla ne. Khathele phela manje. In fact, I'm not well, bafethu. Not well. Didn't want to do this video actually. But I cannot disappoint my favorite student who requested me to do this. In fact, I love all my students because you know what, guys, I wanted to succeed, and I'm glad my students scored distinctions in these past exams. You see, my work is starting to yield distinctions. I don't know, others didn't tell me before, but from 2022, yeah, I started having distinctions. One of my guys is he was doing his second year in medicine at the University of Pretoria, so he's going to be moving on to his third year, so he's becoming a dokotela. Of course, he's going to be entering into clinical years after third year. Now, this is when me and him are going to engage so that he can become as good as he wants to be. But the basic medical sciences, I'm going to leave him to figure them out, because that's a lot of work that someone must learn to appreciate. I can only show the application, just like I will not teach you the rest of the maths, but I'll show you how to use it. Okay? So yeah, another one is doing his BCom degree. He's going to be going on to his second year. You know, another one is likely to join medicine this year. Another one is an actuary. Is it actuarial sciences? Doing actuarial sciences. I think he's doing his third year also next year. Yeah, guys, I've produced, of course, indirectly, because most of the work was done by the teachers and even some YouTubers here. I mean, we cannot deny the fact that this is more of a collaboration than one can claim victory individually. I can safely say we have started producing the best out of these guys recently. So I hope to influence more in this direction, because we need the best guys to take our country forward. We can't have mediocrity as we have right now. A lot of mediocre people are in higher offices of some really, really technical nature. And we wonder why we're not moving forward. Because we don't have thinkers. We don't have people who have capabilities. We have people who have just been pushed there. Now we want people who are going to portray their charisma. We're doing this to simplify your learning experience so that you can learn even technical material that we could not learn. I mean, I don't know maths beyond the grade 12 level. Trust me. Yes, I know certain things that are not taught at the grade 12 level. Because in my first year, some of those concepts have been applied in my studies, like biophysics. Remember, that's still maths. But in medicine, you're not going to do maths directly. You're just going to do mathematical modeling. Okay? Things like dimensional modeling, or whatever you call it. This is when you derive equations for blood flow in a blood vessel using Poissler's law or Poissler's equation. That is things that come from dimensional what, you know. So there's a whole lot of things that we apply. So I know these concepts a bit because we have applied them. I was the guy who always tries to derive equations rather than to just take an equation and use it without knowing where it comes from. So I used to derive those equations, and that uses maths. Sometimes you can do the easy way, the applied way, or the applied way where you're just doing dimensional analysis and what, using those little things there and deriving up to the equation. Or, that one usually just tells about the relationships, the proportionalities, or the actual equation where it came from. I liked to do those. Those were not necessarily examinable, but I would go to that extent because I wanted to understand my work. I didn't want to go to an exam and have to remember what to do. I wanted to go into an exam and work out every problem that comes. I never wanted to read and cry, and then when I don't remember, it's over for me. I read and studied so that most of the work I understand. That means if you throw a question, I can outmaneuver it with the knowledge I have. I never needed to carry a book or to read a book as many times as I can before I can write. The first reading for me had to be coupled with understanding. So that means not reading fast, not moving quickly, but taking time. And then The second reading is revision. You know, there are certain things that are going to play into the background. You're bringing them forth. And when you do that, again, from that first understanding, you're actually fortifying that understanding. Because you start to see how to apply it even in the things that were trying to escape you. Now come in exam, guys, you just go there with your head, You know that most of the questions are going to be technical, so that means understanding. A lot of other simpler questions, it's more like recall. That's not a problem. It's usually common things that you have to recall. So it's not something far-fetched, honestly speaking. Anything technical is what is not common, but you use logic to get to it, provided you have the right information. Anyway, guys, masiqhubeke sendiye ndahlala kakhulu kwincoko and ndithethe into ezininzi. But I'm not happy anyway with that case yala tatomkhulu lawe inhle nolwandle futhi ndazi abasese bahle kutheni bebhayiza nje hawu madala bexhasa mana khangamthuka khangambeka isibhamu entloko mayengafunanga ngevele wamblokha okanye amyeka athi makahlukane naye ingenjalo nza kuripota mhlawumbe ngeyeke nje zibeke umadala ngakhange kuze kufikelele apho xa abantu abangcolile banje. But I sense that that lady is being blackmailed by someone to go this route. The only way they can excuse themselves is to go this route and expose this man, because they want this man out of that position. As for whether he was supposed to do this or not, it's out of question for me, because you'll always be attracted by those around you, because you become comfortable with those people, because you see them every day. They share the same, dynamics as you. But if somebody new from if you don't go to clubs, which is not possible for that man to go to a club and groove. Again, if you go to a club, you are likely to pick up people from the club, because that's the circles you find yourself in. Anyway, let's leave that, guys, but whatever you think, sometimes you need to think about these things, even though we're solving a math problem. Okay, Mary's grandparents deposited 5 scordo into a savings account. Now, the moment you see that word savings, you know that you're talking about a future value annuity of some sort, or some compound interest of some sort. Now, into a savings account on the day that she was born. Okay, now the account pays an interest at a rate of 6.8% per annum, compounded quarterly. That means quarters is like 3. There's 4 quarters in a year, right? To make 1. So now there's going to be 4 quarters here. Okay, calculate the accumulated amount in this account on Mary's 16th birthday. Okay, so this is going to go on for 16 years, literally. That's a very easy question. So, this is nothing but a compound interest thing. So we can say A is going to give us P into 1 plus I to the N. Right. So we substitute that A is what we want, which is the accumulated amount. The principal was 5 scordo into 1 plus, now I, we need to do that in decimal form. This is going to be 6,8 divided by 100. It gives us 0,068. Again, you need to know these guys by heart as well. You must get to a point where you're comfortable. Now this is compounded quarterly, so we're going to divide this by 4. And then here, this is going to be 16 times 4, right? Right, because that's 16 years, but we want to divide that into 4 quarters. So this is just as simple as that, guys. So we can say the accumulated amount is... Okay, let's do it. Very simple formula, substitution, and we go. That is what we do. So we've got 5 scordo into 1 plus, I don't know what I'm doing here, 5,000 into 1 plus 0,068 divided by 4 to the exponent 16 times 4. It's going to be quite a lot of money. Mali guys, yabona ke izinto ezi-rip off lezi zinto lezi. Dot. How man? Imali encinci so. Siqhela kabi. For 16 years, guys. Une-14 sigodo qha. Into enjani na kanti le? 5,000 into 1 plus 0.068 over 4 to the exponent 16 times 4. Hayi. Yo, incinci bafethu ngeke. Iminyaka engaka. Just 14,706 rands now. Money is to 2 decimal places, okay? So this is going to be 56 cents. Hey, yanphoqa. Impoqa le. Iminyaka engaka, guys. And it compounded 4 times a year. Hayi, siyaqhela. Siqhelwa kabi. Anyway, what can we do? Nothing. There is nothing we can do. So this is not right, man. Not even sub 50,000 some change. Robani, man, Robani. Okay, guys, it doesn't matter. This is a nice calculation. The general substitutions and the answer. I hope it's correct because I indenza ndibilayele man. After 4 years, the value of a printer was half its original value. Okay, so if we say x was the original value, then it's gonna be half x. But now fractions can be a nightmare, okay? Sometimes it helps to say 2x so that this is x, you know? Yeah. So choose wisely, but whatever. Now, determine the rate at which the value of the printer depreciated over this period. If the depreciation was according to the straight line method, okay? So that's good. So again, we go and say A is equal to P into 1 minus IN, right? Is that the one? I don't remember this one. I don't use it so much. Maske siyibone iphi. Yes, that's the one. That's the one. Okay. So so this implies now we can choose 2x or x. It doesn't really matter. So this is, it's gone half the amount. So this is going to be half x is equal to x into 1 minus I. This is what we want. And hey man, masingaqhelwa kakubi apha. After 4 years, I was wondering. So this is times 4. I missed this 4 years. Okay, not a problem. So now we want I here. So this is easy. If we divide by x, we know that we will have a half is equal to 1 minus 4i. This implies that I is going to be equal to 1 minus a half. All of this divided by 4. And then of course we can multiply this by 100. Okay, let's see. So simplifying expressions, guys, is key. 1 minus 0.5 divided by 4 times 100. So this is 12.50%. Okay, that's all right. That's okay. That's okay. That's all right. Now let's see if we're gonna get half x if we substitute that 0, don't pi. So we will have 12.5 divided by 100. That is the 1. Then we multiply by 4. We get a half. Indeed, 1 minus a half is a half, times x is half of x. So that's good. So there's always a way of checking if you're not so sure if your operations are proper. So here we're only getting 2 marks. I guess it's substitutions and the answer. Not a problem. Great. Now let's get to 7.3. This is the problem. This is the problem, but it was not a problem at all, guys. Tshepo was granted a loan of 100,000 rands on the 1st of March 2022 at an interest rate of 13.5 per annum compounded monthly. Now, Tshepo agreed to repay the loan over 5 years, okay, in monthly installments of 2,398 cents, starting from the 1st of April. This is just a timeline. Now, guys, a timeline. I have shown you how this thing is done, okay? Must learn how to do it and master it. Doesn't have to be complicated. Capture what is most important. T0, of course, we know that terms follow natural numbers, but at term 0, this is when we borrow the money. The 100 scored, right? Right. And then we are starting at term 1. The repayments of 2,398 cents. And if we're going for a 5-year period, this is going to be T60, right? Because monthly it's 12 by 5, that's 60. So we will still be paying that amount, hopefully. But in any case, this is what was decided. So we're still paying that amount there. Okay. And we are told that this is at a rate of 13.5% per annum compounded monthly. All right, not a big deal. This is nice, easy, not a problem. It says calculate the total interest you will pay over the 5 years. Not a problem. Very easy question. 7.3.1. We know that the interest is going to be the number of payments, which is 2,300.98 times 60 minus the original amount that he took. Okay, let's deal with it. Okay. Let's see. 2,398 into 60 minus 100 squared. Please, guys, key here is to make sure the calculations are proper. So this one is 38,058 rands 80 cents. Okay, that's the interest. Not a very difficult question there. Easy stuff. This is a calculation. That is the answer. Okay. Now we are told Tshepo paid 22 scored 33.98 cents. Now his monthly installment and an additional, basically this 22,000 is made up of his normal installment of 2,300 rands and an extra 20 scored on the 1st of March 2024. Now that is 2 years later, right? It was 22 to 24, that's 2 years. Now into the loan account. Now he continues to pay the original monthly. So if he continues to pay the original monthly installments thereafter, now it says how many months earlier will Tsepo repay the loan? Okay. Now, if you look at this question, one thing needs to come to mind is that when we pay this amount, we need to know the balance outstanding, right? That's the main thing. So this is the question that couples balance outstanding, and then whatever that balance is, we then calculate by using this same amount of money. How long will we take to pay that? Then, obviously, if we reduce the balance outstanding, because, if we're paying on normal installments, that means the balance outstanding after 2 years of paying that installment, we'll then cut it by 20,000 rands. Now, there's something I want to tell you guys. The balance outstanding is without interest. Always remember that. If I borrowed you 2,000 rands, and you're paying maybe installments of 200 rands a month or so. Now, when we're talking about the balance outstanding, let's say the balance outstanding now is 700. That means from that 2,000, you've only contributed to what? 1.3 to 1,300 rands. Plus interest on that amount of money, because it's all about the period you keep something that is not yours. If you keep something longer, then you will pay interest on it. But if you don't keep it longer, then you don't have interest on it. So literally, the balance outstanding is the amount of money without interest from the original amount that we borrowed. And that means if you decided to just put that balance at that point in time, then you're cutting the interest. Hence, the banks will always give you a headache and say, if you do that, then you're cutting interest. That means you're wasting their time, because the agreement was that you're going for the full 60 months. And now if you're going to do less than that, then that means you're going to kill them, because they're not going to have interest on your money. Because remember, that balance outstanding, if you pay it, that means you will pay that money without interest. But of course, these people are smart. When you want to pay that money, they will tell you, no, we will negotiate how much you need to pay to settle this, because they still want a portion of it to be some kind of interest. So they always like to, it's a penalty, and they are lying. That penalty is no penalty at all. They're just going to push you to paying the amount that you would have to pay anyway. So don't be fooled. When you pay the balance outstanding instantly, that money has no interest in it. Okay, just remember that. So this guy is trying to cut the interest, basically, because on the balance outstanding it's going to be smaller. And if you keep the same installments, then they're going to be less than what you would if you did not pay some money where it cuts the interest. So that's why it cuts the interest. So remember that story. So again, guys, financial literacy is key, because if you don't think of this thing practically, then you're just wasting our time. Thank you very much. So we know, guys, that at some T24, because that's 2 years, right? This amount of money was put in. So this is 22 squared 33. Okay, this is what we put there. Of course, we are paying this usual installment and some extra 20 squared there. So this is it. So this means all we want to know is that over this remaining period now, what is the balance outstanding? And the balance outstanding, we are going to take out the 20,000. because we're going to cut interest with this 20 scored. And if we cut interest, that means we'll pay less interest than we would have if we went the full period. And that's why the banks are not happy. They will always say, if you want to pay now, whatever is remaining, they know that if you pay it, you'll pay it without interest. That now must negotiate, we'll get back to you. So bhatala imali ethile ngelo xesha bafuna ukuqothula. About demet. Yazi ndiyakuxelela uzazi izinto ungazudlalwa zezimfene. Xa bengabe futhi befuna ukubhayizela, baxela bajongana apha nina. Faka kwi-commercial what. Amagqwetha akhona wazi i-commercial law sani. Vele uthi okay, mna I'm gonna call my lawyer guys. Kuyanyiwa qa. Manyiwa makuvele kunyiwe once, yabo. Singabe siqhelana kabi. So anyway, ngoba ningamagwala nina xa benigwajisa ezazibhanqa vele nitatazela. Abantu abakhona abangayenza. Xa bathatha basecourt you will win because hey, you allowed to pay like that xa ungafuna ukuqhubeka. Noba ngathini. That's why now beza kusayinisa eza contracts ezisinaks ezinezinto ongaziboniyo. Beza nto ongaziboniyo zizo kanye ezenza sure ba awuzoyenza lento endiyithetha. That's why ifuna xa uthatha into ungayi desperate ba. Noba so desperate kangakanani, ufike ngathi awukho desperate sana. Uthi ndizifuna apha zonke izinto ndizifunde. Azogqibile then wenza into zakho uzawubona, you'll be happy. All right guys. Now we need to find the balance outstanding after we've paid this amount of money, this 2,000 what, right? But from that balance outstanding, in fact, this would be the balance outstanding including this cut right there. So the balance outstanding here, guys, is going to be essentially balance outstanding here is going to be the future value, the present value, right? We write the formula x1 minus 1 plus I to the minus n all divided by I. But to this one, we're going to subtract the 20 scored because that would be the balance outstanding. So remember that. So you can do this in many steps if you like, but andikuthandi ukuzisokolisa mina. Ndithanda izinto ezingasokolisiyo nje. I like to suffer less. Now remember guys, we're going to write the amount that we're paying, 2,398 into 1 minus into 1 plus 0, when we divide that by 1,000, it's going to be 135 over 12. Now to the minus, now remember, we're going to say 60 minus 24. That would be 38, right? 36 now. 36. 60 minus 24. That's 36. Because remember, we've already paid this amount now at T24. That's why we don't count it. So what remains is just 36. Now this is going to the minus 36. So remember, the balance outstanding is going to be the remaining payments that we still have to pay. But now we're eliminating the interest this way. That negative eliminates the effect of that interest, literally. Because that's more like the reverse operation if you think about it. So understand these things, guys. Don't just plug and go blindly. It will be used without you knowing, or in fact you will think questions are difficult when in fact they are not. This is a very easy question if you accept that you need to study for understanding. Don't just know how to substitute and go. The balance outstanding after this 24th payment is what we will get over there. So let's see. Our calculators can handle this. 2,398 to 1 minus into 1 plus 0,135 over 2. Again, guys, the exercise here needs to be very well structured. Don't make a mistake here of don't make a mistake here in terms of substitutions. It can be very technical because there's too many things to write here. Sometimes you can decide to do it step by step. So what I'm getting is 47,804. Now we can decide not to round off if we like, but this is money, guys. So this is 9. Okay, 36, because now this is not the final answer. This is our way to the final answer. Why is my B looking strange now? Okay, so that's it. So this is the balance outstanding. Remember, guys, this is the amount from the 100,000 that we got without interest, because we undid interest when we say to the minus in terms. Okay, just remember that. Now what are we doing? We then say, okay, how long are we going to take to pay this off if we continue with these installments? Remember, we cut the interest here. This 20,000, we cut the interest that we would have had to pay by paying it like that. It's more like a deposit. If you think about it, if you took 100,000 and put a 20,000 deposit, so you will actually be charged interest for 98. Is it 98? 80,000, sorry. You would only be charged interest for 80,000, not for the full 100,000. That's exactly what that does. Okay. So now we need to do the period on the outstanding balance. Because if we do the period on the outstanding balance, if we pay this, it will give us exactly the number of months that we're going to pay this off. Okay, so we can say then we know that still this amount of money, at this point, I'm not interested in suffering and rewriting the formula. If I've done it somewhere, I'm only going to use it. Now, I know that this 47,804, 936 is going to be given by these installments, which is 2,398 cents into 1 minus 1 plus 0,135 over 12 to the minus n. We don't know this n this time. That's what we want to find out. When are we going to quickly pay off this? Okay. And we have 0,135 over 12 right here. That's all. So our job is to find n using the present value, because it still tells us how quickly are we going to pay off this amount of money. Okay, of course interest will be captured there as well. Okay, all right, okay. So now we cross multiply that, we divide by this, and then we break this up, and then we move this, and then we move that. So for me, guys, if you haven't learned how to do this, we can say, in fact, let me just do this. This implies that n is going to be equal to minus log. The base is going to be that expression. I know it. It's 1 plus 0,135. So learn how to do this so that you don't need to struggle when you get here. Now the big bracket here, which is for the number, it's going to be 1, this one, minus this multiplied by that. So it's going to be 47,804,936 times 0,135 over 12, and this we would have had to divide it by, this installment. So this is 23. So if you watch my videos, this is effortless, guys. This should be very easy. Now therefore n is going to be equal to, so let's go to it. So So this should be second nature, honestly. If it's not second nature, please kill yourself. You are not serious. When others are learning and we are taking time here of our hectic duties, when Nanjubis we are put up, we don't do this for fun, guys. We care about you. Remember, this is us caring about you, not some stint at popularity. That's something that pays nothing. A lot of popular people are actually suffering while they pretend to look like they are not. Of course, not all, but most. So guys, I'm getting 23. Of course, now period here, it just says 23. So this means we're going to pay 2,300 rands and 98 cents. And then the other one is not. But again, we're not interested about exactly how big the other one is. We just care about the number of payments. So we round up. It's going to be 24. Okay, that's going to be 24. Now we know that after this, remember, after we have laid down the 2,300, we would still have 36 payments to pay, right? But now that we laid down the 20 squad as well, so that we can cut the interest, can you see we end up with 24 payments instead of 36? So how much earlier is this going to be? We can say, therefore, Tebo, a friend of mine, is going to repay the loan at 36. Remember, that is what he would have had to do, minus 24 now at 36 minus 24 months. Okay, which is going to be just 12 months earlier. Okay, so this is it, guys. I mean, there's a whole lot of things to say, but maths, a short sentence and some calculation within it is also acceptable. So let's see, 36 minus 24 is going to be 12. Yeah, man. So this one is going to be 12 months earlier. As you can see, guys, this is how finances work. So please don't be fooled. Of course, these guys take up a whole lot of interest when it's them. Look at how much they get in 5 years. Interest is 38,000. But if you looked at somebody who took a bit of a moment, what was it? Can you see, guys? Come on, man. Okay, it's quite big though, but yikes. This would work back in the days, not now. 14 squad is nothing nowadays. In fact, 50,000 is nothing, guys. It's like you have 5,000 back in the days. That's what you have. Only 50 squad, only 5 squad, literally. Anyway, that's how easy this question was, guys. So you needed to understand how to deal with these issues and what you need and what to do with it, and by understanding exactly the construct. So you see, mastering timelines and mastering the topic. I mean, I have given you more examples of how to deal with this. Of course, with each video, sometimes I drop a few more, points that I may have not made before, or sometimes points that you may have not understood before. But more or less, we're doing the same thing. It's just that we need to know when to do what, and what are we going to get with it, which we're going to use it where. Okay, so this is it, folks. This is it. Now this 7 marks is creepy. Okay, first, this 36 is something we calculated. See, having a timeline is nice, right? And then we can say the general substitutions here, including the 20,000, sorry. So getting that balance outstanding is important, and finding the period with which we're going to do that. And then this calculation is important. So we've got 1, 2, 3, 4, 5. Now this gymnastic is somewhat key. So we can say, if we use the law, this is more like a log rule or log law or whatever. So if we use a law, you get a mark. So that is the 6th mark. Where is the other one? Where is the other one? Where is the other one? Iphi enye. Hayi nama ndiyiboni iphi. Okay, mhlambe sithi 2 marks for the answer, guys. Sometimes it's like this, because you can see we've had to calculate it somewhat. Okay? Because the rest is history. So there's our 7 marks. And a very easy 14 marks. Okay, maybe the last question could have taxed you a bit in terms of thinking, because if you don't understand what represents what, it's especially the balance outstanding, if you don't understand what it stands for and what it does, you'll certainly not know what to do. Okay? But be very careful. Some people make a mistake of using the future value calculation instead of the present value calculation here. And they get this wrong, because then it gives them a wrong answer. I don't know. Maybe it gives you the right answer, but I haven't seen. I don't know, if you used the present value, what would you be doing? Because this is the money you have now, but there will have been interest later on anyway. So yikes. You think about it. Anyway, okay, let's get to calculus, guys. I'm losing time. I didn't want to lose time. I started talking about our judge president Mbenenge issues there, but for me, honestly, women are just not fair, actually, because they know we love them. Now they want to use that against us. That's not right. No. People cannot be targeting other people's jobs just because they can't fight interpersonal warfares. This thing is between 2 people, okay? It must not be brought to issues of work and what. You like a woman naturally as a man, okay? What we can do here is that if someone expressly refuses and then you use your powers wrongly, it cannot be assumed that you used your powers just because you're in a high position. No, I don't disrespect anybody. Even the people that people mostly look down on, I don't. Although when I'm at work, I'm at a higher position than they, but I still treat them with respect. If they're older, mama, tata, bhuti, sisi, sisi. Kamba, I don't care for them to call me doctor this, doctor that. If bandibize ngegama lami xa belazi, I'm happier. If uthe mntanam ugqibile, bhuti ongandaziyo ugqibile, I don't need to be called a doctor, because it doesn't mean anything to me. That's just something written on paper. I wasn't born that. It's just on paper. It only tells somebody of my responsibilities where they find me. But personally, nothing. Okay? Now, people are going to use this now and say, used his power, or maybe people got fired. Those people got fired, yes. If that was done, then they must bring up a case in front of a court and let it be contested. And if it's found to be so, then... But you can't assume that if something like that happened to somebody else, it will happen to you. The rights, guys, nowadays are very clear. And the law is very clear. Of course, people are always going to manipulate things because they know people in places that we don't know. That we cannot deal with, because there's no logic about it if you don't have a fighting spirit. This is why you need to be someone who keeps to themselves if you don't like to be subject of certain things like this. And anybody who seems to suggest anything otherwise than just a professional relationship, then you quickly hit that hand. It's like a child. If you don't deal with the child early, you let the child always get to touch things they're not supposed to, then you'll always have to deal with broken things in the house. Because until you stop them, they will not stop on their own. But if you hit them before they touch certain things, then they will be hesitant to touching things, even in your absence. Because they will know, you will know. For example, if you put something somewhere and then a child misplaces it or changes the position where it was, if they get a hiding for it, they will know that it's not so easy to maintain how things were. And so they will stop. And that's how exactly we should relate even at work, because we're still human beings. We're not animals caged in cells, we interact. Some of these relationships go on to become, families. Families are built from these relationships because, I'll see a pretty pharmacist today and be like, yo, this one is my wife. But from interacting with them regularly, then, hey, I become interested. Can we go on a date? We go. And then from there, I start saying things now, showing my interest. And then if she likes it, we date. Of course, when things turn ugly, of course, there's going to be a fight. Then, if that woman wants to use this against me now, she's going to try to play a victim. It's ridiculous, man. She was playing along all along. Now all of a sudden, because now things are no longer sweet, now she wants to make this look like now she was being abused. No ways. No ways. And you can't come and tell me that I cannot have a relationship at work if I want one. As long as I perform my duties. As long as it does not interfere with my work. You can't tell me that, okay? But then if I'm going to go and sit with my girlfriend at her office in the pharmacy department and then she doesn't dispense medicine and I don't see patients, then that's a problem, okay? But if she wants to come here and spread my dirty laundry because now we're fighting, that's her choice. But I don't think authorities should entertain that. It's ridiculous. But where there is a case, say for example, take an intern. I said to that intern, look, if you don't do this, you don't date me or you don't sleep with me, then I'm not signing your logbook so that you don't get qualified as an independent practitioner. Now that's a problem. Now that's a problem, and that's worth dealing with, okay? That's worth dealing with, because the day I decide not to sign, if you refused, then you can take it, because then I will have acted inappropriately now, using my power against you. You get it? But at the same time, you have a responsibility to also show now that you've been performing your duties well, because they can use that against you. I mean, people, man, are always going to do things to each other. No matter how much we want to interfere, we'll never get it right if we use this emotion and prioritizing certain genders and suppressing others. At the end of the day, we have been given an equal field of opportunities. We have to just take those opportunities, okay? And what we do to each other at a personal level, for me, it's all about how you deal with it. If you can't, then you seek help. Then if help fails, then we can start talking about these kind of things. That this person doesn't listen even when somebody else intervened. But to just jump and want to destroy people, then yes, it's easy to do that. But now there will be retaliation. Now there's these ugly killings, all these other things. Because people did not need to kill someone they don't agree with in the past. Because they knew nobody's going to interfere. Okay? Even if they lose, they're not going to be targeted personally. Because if you're going to target somebody's work just because an interpersonal relationship fell apart, it's ridiculous. Now, if you start to threaten me in that order, then I will have to kill you, right? Because I have to protect my reputation now. Because I know you're going to drag me. Because that's what you guys do anyway. When you fail to face the music, you want others to feel sorry for you. Sometimes I don't understand women, how they think. These are the strong people, by the way. These are the people who nurture the world. They feed children who are the future presidents. They raise them, they teach them. I mean, female teachers are the best teachers you can find compared to males. These are the people who are actually the very progress in society. But now they're just turning into nightmares. They're turning into monsters. And now if those people turn into monsters, society breaks down. Because we are animals by nature as men. I'm saying it without categorizing it, or without a shame. We are hunters, guys. We will always use our masculine influence into things because that's our nature. But trust me, where people behave well, they respect themselves first before they can demand respect from others. Automatically we give them respect. I grew up in a village where women are not treated carelessly or abused, but they also know their place in society as well. And the roles are not mixed. Men have their own responsibilities, women have their own responsibilities. Yes, there are some that we can share, but there are certain that we cannot. And where there's such uniformity, there has never been problems of this nature. But where we jump around, we do as we please, there will always be issues, because who must always sacrifice their own rights for another person's rights? Because where we can reach a mutual agreement, there will always be issues, and of course abuse of power will kick in, because you use whatever means necessary to defend your position or to gain what you want as a person. Anyway, guys, I must see you again, Linda. It's not that I've ever been a victim. In fact, I'll never be a victim of such nonsense, because even if someone tries, you can just kill them, right? I'm just trying to breathe, okay? Although I'm breathing a bit wrongly, because some people will take offense. I mean, people are fragile, we know. Okay, we need to do d over dx. So we're doing the derivative with respect to x of this expression, 3x minus 5x squared. Now we can write equal to. Then we do the differentiation. So this is 3 minus 10x. Done. Okay, this one is easy. We get a mark for each of those terms. So 8.1.2. Again, we need to do the derivative of this function. So now this function is not right. Once we see a square root, it's not ready for differentiation. So we start by sorting it up. So we've got 2 over x squared. Now you see x in the denominator, it's not ready for differentiation. So this is the cube root of x to the 7. Nice. So now we need to first sort up our g of x. This must go to the numerator. This is going to be 2x to the minus 2 minus, now the cube root is going to be x 7 over 3. Okay, that's what this is. Okay, or someone who wants to see it more properly, but I mean, I don't have time to waste. This would be x to the 7 like this, right? And then we simply multiply exponents. So this is going to be x to the 7 over 3. Okay, so this is what we need to do. Now that everything is ready, we can say therefore g prime x is going to be minus 4x to the minus 3 minus 7 over 3 x. Now if you subtract 1 there, it's going to be 4 over 3. Okay. Erikebone, is it so? Let us see. Yes, yes, that's the one. Okay, guys, now here there's no point to bring back the radicals and stuff. We normally don't like them anyway. But negative exponents are usually frowned upon, so you may want to change that, but nobody cares in grade 12. At least I have not seen anything that says change negative exponents. Yes, they are frowned upon in grades before, like grade 11, grade 10. We frown upon negative exponents. Radicals already frown upon them anyway. You can't leave an answer like this unless stated otherwise. So now that it's not there, we don't need to bring it back. Okay, that's it, guys. So, of course, how many marks are we scoring there? 4 marks. Lord have mercy. This and that, because we're using some rules, and then the differentiation. I suppose this is how we score those 4 marks, okay? Yeah, guys, I'm a bit tired. Now it says determine the equation of the tangent to this expression at x is equal to whatever. So this is good. The equation of the tangent would be the gradient of this thing. But first of all, we need the point of tangency, right? So we can say the plot is such that we've got f of 2 equals minus 4 into 2 square cubed, sorry. Okay, I missed something already. So this is going to be 2 cubed minus 4 into 2 squared plus 2 into 2 plus 3. Let us see. Of course, don't show up with things like plot. Write point of tangency first. Okay? Maybe I should have done that. Let me not teach you bad things, but let me first evaluate. 2 cubed minus 4 into 2 squared plus 2 into 2 plus 3. This is minus 1, okay? Okay, now let's do this. So when you write things that nobody knows about, you can just say at point of tangency. You can now write port. You see, it is such that. Then you do these kind of things. Then you can say, therefore, the port is 2 minus 1. Very important. Now we understand what the port is because we introduced it. Remember, when you introduce things we don't know, please introduce them nicely and kindly. Okay, guys. Now, what else do we know? We know that the gradient of a tangent is equal to the first derivative of this function at this value. So we can say, well, the gradient, we know that the gradient, can say m tangent is going to be equal to f prime at 2, right? Which we can go on. The derivative there is going to be 3. Instead of x, we put a 2, but then it's going to be squared. Okay, guys, you can do this quick. You can do it slow. It's up to you. This is going to be 8. Then we put a 2 there. And then this is going to be plus 2. That's when we differentiate. Remember, this one will lose that x. And so that's it. We get the gradient here. So let's see. 3 into 2 squared minus 8 into 2 plus 2 gives us minus 2. Okay. Now, once we have the gradient, we can say, therefore, the tangent is such that y is equal to minus 2x plus c. Now the part is still part and parcel of the tangent, because at that point of tangency they share the point, they also share the gradient. So it's going to be minus 1. What? Oh yeah. Minus 1 is equal to minus 2 into 2 plus c. Therefore c is, this is minus 4, that side we get 3. Therefore y is equal to minus 2x plus 3. I'm surprised this question is 3 marks. Ha. If they said the gradient of the tangent, I would understand. But the equation of the tangent, this one is the one. Because guys, to differentiate is a mark. To get the actual gradient is another mark. So for me, this would be 3 marks. But to say the equation, maybe they wanted to say the gradient. Let's forgive them. Because it doesn't make sense to say the equation and then there's 3 marks. That's ridiculous. There's so much that we need to do there. But hey, whatever, man. You see, this would be worth 4 marks, in my opinion. But you know what? It is what it is. So nanzo bhali marks ezibhadlileyo ndiziyeke zezingenangqondo ne. So 8.3, we are given this function f of x is equal to minus 6x squared. Now 8.3.1, we need to do the definition of the derivative. So we know that f prime of x is going to be f of x plus h minus f of x. Where did I get this? Am I dreaming? As guys, I need to be studying. Hey. Otherwise, I'm going to fail my exam when it comes. At the moment, I don't know if it's going to come or not. But when it comes, I'm going to fail. I must not be doing this maths for you folks. I have finished doing maths for you. Okay, f of x plus h, this is going to be minus 6 into x plus h all squared minus into minus 6x squared over h. This is the limit as h tends to 0. Then we set this up. This is going to be minus 6x squared. This would have been 2xh. So this is going to be minus 12xh plus h squared is going to be minus 6h squared plus 6x squared over h. Of course, guys, you can separate matters here if you're not comfortable with this. Lim as h tends to 0. These ones go away. So we have minus 12xh minus 6h. This is too long. So this one we need to go about it step by step. No manga business here. Limit as h tends to 0. We factorize here, but this time we're not necessarily going to take the highest common factor. We just want h out. So minus 12x minus 6. Hi. This is h squared, man. Yo, ndimangele. Neseki markets. hore hobaneng jwale e ka re ntho ya ka e batla ho nketsetsa dintho tse sa tsamayeng hantle na. Now guys, we can drop the limit. We've got minus 12x minus 6 into 0. That is the answer there. So literally guys, this is easy. There's no question about it. Using the power rule, we get minus 12x anyway. So if we get it, we know we did it the way we are supposed to. I'm not even gonna mark that. So we've got 8.3.2. Now, this says write down how you would restrict the domain of f such that f prime, not f prime, but the inverse of f is a function. Of course, this is a parabola like so. It's just steep, that's all. Hey, this is something like so. Anyhow, that is the origin x, y. But now the problem here is that the inverse is going to look stuff like this. The inverse is going to want to look stuff like that. You see? Now, if we do a vertical line test on this inverse, it fails. Okay? It fails the test. So for it to pass, we need to restrict. Either we restrict the graph that way, or we restrict the graph that way. To see that it's just one mark, we can just do one restriction and we're fine. So we can say here x must be less than or equal to 0. See, because if that's what we do, then our graph of the original function is going to be like this. And what would be the inverse look like? The inverse would look, sorry, if we restrict this one, yeah, it's gonna look like this. And if we draw any vertical line, it will pass, right? It can pass la test a vertical line. Okay, good. So it will pass it. So that's it. So that's the story. That's the story. Okay, so that's it guys. It's just one mark. So 8.3.3. Now we're told to determine the equation of the inverse for this one to be less than 0. Is write your answer in the form, okay. Sorry. Now let's see. We know that f of x is basically minus 6x squared. Now we know that this implies that the inverse would be such that x is equal to minus 6y squared. This also implies that, oh no, not like this. This one shifts the position to here. Therefore, this implies that y squared is going to be equal to minus a sixth of x, or we can say x over 6. It's not a big deal. Minus x over 6, which implies that y is going to be equal to plus or minus the square root of x over 6. Okay, now we want our inverse to be negative. So for our inverse to be negative, it means we will say, therefore, we know that this one is going to be given by this minus the square root of x over 6. Because for this to be negative, we need to drag that negative. Or we were told in the form y. So we need to pay attention to the requirement. We already stated what this was. Okay guys, this is not a big deal. So swapping the 2 is good. Picking the answer is good. Taking the square root here, I guess, is the third mark. But now, I don't think the third mark is there. It's actually wrong. No, that one is nothing. But we need to state the domain here for this to be the case. Now, we can say x is, now can we have x as a negative? No. So x must be greater than or equal to 0 itself. Now that is the one. So we need to restrict this answer so that what is under the square root is a real. It has to be a real. So the extra mark is for that restriction. Without it, wangwishish. Okay guys, yo, relax. I was supposed to be done. Yo. I must call this thing. I started talking. Ingxaki abafethu ndingumhlali wasemzantsi weAfrika, so ingxaki ezivelayo kweli lizwe funeka nam ndiziphefumlele, yaqonda? Ngoba ke mandilifumana ithuba lokuziphefumlela kwenye indawo, funeka ndiziphefumle khona apho ndidibana nani khona. Because this is where I meet you guys. So now we're told here, A with those coordinates 1 and 9. B, these are the turning points of this graph. Okay, good. So this is the minimum, that's the maximum. And then C is just the y-intercept. We can see there, we can appreciate it. And we can appreciate this a cubic function, and the shape is telling us that the A at all is greater than 0. Because of the shape, like so. Okay, that's why we know. So if we ever have to find the equation, we know this is what we're looking at, okay? Now it says, for which values of x is this graph decreasing? Now decreasing means negative gradients. Okay, now if we draw tangent lines here, on this side, we will see that we will have a positive gradient before that turning point, because the slope is like that. But if we do a tangent on this section between the two turning points, it carries a negative gradient, and then if we do it beyond that turning point, it carries a positive gradient. So this is decreasing between those two. So that's nice and easy. 9.1x must be less than 5/2, but greater than 1. Because the question is on the x values, so we get our 2 marks there. 9.2, it says, write down the x-intercepts of f prime. Write down the x-intercepts of the first derivative function. Now, of course, we know that the x-coordinates of the turning points are the x-intercepts of the first derivative function. So, if it says the x-intercepts, we just write x-intercepts of f prime x as such that, do we write in coordinate form? The question didn't really say coordinates, but x-intercepts are a point where we have x and y. Problem is, Oh yeah, the x-intercept, we know that the x is this one and 0, and the other one is 5/2 and 0. I don't know what happens if you write x is equal to 1 or x is equal to 5/2. Even if you didn't say that, but you say, and I don't know. I don't know what happens if you write your answer like that. Because the question didn't say write down the coordinates of the x-intercept, but x-intercept is a point, so a point can be looked at in terms of the coordinates or just the x values if we're saying x-intercept. So but those 2 marks, I think no one will take them away either way. Now, for which values of f will this be concave up? Okay, I mean of x. Now we know that the average between these two, the average will give us the point of inflection, the x coordinate at the point of inflection, which will be right around there. So the average there, this point here, x is going to be equal to 1 plus 5/2 all divided by 2. Okay, that's it. So we can just say x is equal to 1 plus 5/2 is basically 2,5 divided by 2, just to avoid unnecessary stress. But again, guys, a question like this, sometimes we don't really have to show a calculation per se. An answer only is okay, but there's no punishment for no answer only. But remember, if you don't show an answer only, and then you end up showing us a wrong framework with the correct answer, then you are already defeating yourself. You get 0, okay? So if you show us how you did it, and that is wrong, you are dead, okay? You are really dead. Because we didn't have an equation here, we only had points, we're going to use points. Alright guys, so this is it. Again, 2 marks for the answer. But if you show this step, you will get a mark for that step and get a mark for the answer. But if this step, you show it and it's wrong, and you end up with the right answer, you lose both marks because it means you copied. There's no way you can have a wrong framework and then have the right calculation. We don't care whether you made a mistake in writing, but you did it correctly when you calculate. We take you down, okay? That's just what it is. You can cry about it, we don't care. My ears are biting me, man. They're biting me. I don't know why, because I'm not scrumptious. Anyway, let's see, guys. What is the next question? Nature of roots. Nice and easy. It says now determine the values of k. Now k is a constant. Always remember that. So for which y equals f of x plus k. So now this means it's a vertical shift. Whether up or down, will determine the value of k for which y equals f of x plus k will have 3 positive x-intercepts. Okay, that's fine. So obviously we need to do a down shift because this already only has 1 root or 1 x-intercept. So now if we want to keep 3, it means the line must cut here. It's either we're saying k must be the line like so. Yeah, maybe straight, man, maybe horizontal. Okay, if but if k is like this, meaning it's limited by these values 8 and 9, if this is the line y is equal to k, we can clearly see that even though this could be looked at as a vertical shift, but this simply says, yes, we can shift this graph by 8 units down. I mean by more than 8 units down, but we can't shift it by more than 9 units down, because then we lose these ones. Or we can just decide to draw a line. If we draw a line down here, it only intersects once. We draw a line over here, it intersects once. At the y-intercept, once. In line with this turning point, only twice there. And at the turning point, at that level, it's going to be at that turning point and there only twice. But in between, we can appreciate that would be an intersection, intersection, intersection. And all of these are on the positive x-axis. So, so that is what we want to say. So that is very easy, guys. I hope it makes sense. If not, please shout in the comment section. Sometimes I will assume that you follow. So this means k must be equal to, it means k must be less than 9 but greater than 8. Because we can see if k is 8, it's only going to be this point and the other point, just 2 points, not 3. If k is 9, we only have that point and that other point, so there's just 2 and not 3. But in between 9 and 8, we can see that we get 3 points of intersection there. Or we can decide to just shift this graph down. Let me just show you guys, in case you didn't get what I was saying. Sometimes it's easy to think you guys follow, but you don't. And then look at this graph. If I push it down, let's say now I'm going to take it down 8 units. Now that means this graph from there, I'm just taking that point B to the x-axis. Can you see? If I'm taking it down 8 units. Now can you see I only have one x-intercept and another one. Yes, they're both positive, but I don't have 3. Okay? Let's say now I take it down 9 units down. So that means I'm taking that turning point down to the x-axis. Can you see again how many x-intercepts do I have? 1 and 2. But I don't have 3. Okay? But if I shift it so that it's not more than 8, but it's less than 9 units down. Can you see? This is less than 9 units down, but it's definitely more than 8 units down, because 8 lands us there. If we take it further, that's more than 8 units down. Can you see we have 1, 2, 3 positive x-intercepts? So that's another way of looking at this question at some point. But it gets confusing when you have to calculate by how much did you take it down. Remember, if we take this vertically down, if we say 9 minus the value there, it's going to be less than 9. But if we say this goes all the way down there, then we will see that it's exactly 9 units down. But if we went further, as you saw, we don't get 3 roots or 3 x-intercepts. So it has to be like this for it to work, okay? It's either you do this shift. Now, if you guys have, when you buy your phones back in the days, the cables are usually tied with something that is, that soft wire there. You can keep that in the exam. I doubt anyone will punish you. Just shape it into this graph, because you can't really shift this in the exam. Just shape it into this, especially the main parts. Then you just shift it up and down. You will be very happy. If you watch one of my older videos when I was using my camera, you'll appreciate this. So there's many ways you can help yourself win. Don't lose. The idea is do not lose. So there's our marks, guys. 2 marks. Very easy, 8 marks. This question was made easy. And usually this is very easy. The cubic function is very easy. Actually, differential calculus is easy. That's what I can say. Now let's get to 10, where we then optimize or we apply calculus. Okay, guys, I'm a bit tired. Let me move a bit faster. Now, we're told a cyclist rode from town P and stopped at town T. Okay, maybe let's do this. Road from town P. What I wanted to highlight is the fact that it stopped at town T. But what is important is that stopped. Now, if you ride from, it means it depends whether we looked at you when you were passing town B, because there's another thing here. From does not necessarily mean you started from 0 speed. Of course, it may imply that in practical terms, but what if we caught you when you were passing town P, for example, and we looked at you as you rode until you reached town, say town, what is that town again? Town T. So that's still riding from town what to that town. Even though you may have been riding previously, you did not necessarily stop at town P. We may have caught you passing it. In us, or from us, you would have been riding from that town to the next town. So this one, you see, questions of application sometimes can twist your head a bit. You need to be very cautious when you approach them. This is why understanding the statements given is more important than rushing for the questions. Now, the speed in kilometers per hour, again, look at the unit of measurement there. It is very important, at which the cyclist rode is represented by this equation. But now, if we look at this equation, is the first derivative of yet another function. Now, we know speed is the rate of change of something, so it's some kind of a gradient. So this means the original function was the distance function, meaning s at t must have been a distance function. Now remember, here you need to do the antiderivative. If you're given the derivative, you take the antiderivative to get the original, at least. Now we know that to get that, we just say divided by 3, then we get minus t, and then we add 1 there, it becomes t cubed. Plus, here we divide by 2, that's going to be 9. Then to t we add 1, 1 plus 1 is a 2. Then of course, here we don't know now, the cx part is not here. So does it exist? Does it not exist? Well, if it is not part of this expression, it means there was nothing here. Here there was nothing. There was 0t. Okay? Plus, now here we can just call this one k or d if we like. Let's just call it d. Now remember, already when we did that differentiation, this may have been there. We can't just say it wasn't there, because a derivative of a constant is 0 anyway, so this would have fallen off. Okay, but this one we know for sure did not exist. So 0t did not exist, because if it did exist, we would see the constant here. Now that we don't have a constant, it means there was nothing here. This term did not exist. So again, inspect things, guys. Inspect things for what they are. Now we know this is the situation here. The original function, which is the distance function, was like that. And then when we differentiated, we got that. Now doing the antiderivative, guys, I don't know if it is being taught, but I was taught in school. You know that old classroom mathematics, the pink one, by Sir Loredin and his colleagues. It did show us how to do the antiderivative. So I don't know if it is still being taught. If not, then it's fine. You can forget about it, but this is a skill that is pretty easy. I mean, even by inspection, you can think about it, guys. If I had initially ax cubed plus bx squared plus cx plus d. When I differentiate, let's say this was my f of x. Now my differentiated thing, we multiplied by 3 times ax, and then we subtracted 1. So it's that 3 minus 1, right? Now to undo this, we need to get rid of the 3. Obviously, it makes sense to divide by 3. Ax squared. Now to undo the minus, you add. back. See? So even by inspection, you don't need to be taught certain things, guys. You need to get to the habit of knowing how to look at things and say, if this is what I had, how would I go back? You just undo exactly what you did. Reverse operations. BODMAS. Guys, I showed you these things not for fun. I'm teaching you these things. Okay, maybe let me not say I'm teaching, because I'm not a teacher. More of a fanatic. So I'm literally showing or demonstrating these things to you guys so that you understand. Now remember, the next one here would have been plus 2b x and then 2 minus 1 again. And now we know very well that if we want to undo this back, we need to divide by 2. We're going to have 2b x to the 1, obviously, which is what would remain there. We divide by that 2 which we multiplied by, and then we reverse this by adding it back. So can you see it makes sense what we are doing here? We're just undoing what happened, because we can take this there, because we know this is a constant. Remember, d here is a constant, so don't worry about it being a variable. It's a constant. Okay, guys, so I'm taking a bit of a moment to teach you something, because I know there's no time to teach you these like formally. Certain things are best looked at as you deal with them, so that you can also learn the skill of doing certain operations. Okay, so guys, for this to be 0, it means this constant c was 0 anyway. So this was essentially 0, so there's nothing we need to do about it. But as for this d already disappears anyway in this, so we can bring it back, because we can't be ignorant and say it was not there. Remember, this is nothing but modeling. If you think about it, we're modeling this cyclist's speed by using a cubic function. In a way, this is just another way of making maths a little bit spicy. That says speed is the rate of change, just to show that this is nothing but the gradient of distance function. Okay, so it's a rate of change. It's just the gradient of a distance function. I don't know what I'm doing there. Okay, let's just leave it at gradient. I think it's fine. But I'm not happy with that statement, the way it looks. Okay, so we know that if we're talking about the gradient, we're talking about the derivative. Okay, derivative means we differentiated something. Okay, so don't say you derived. No, deriving is another story. To derive is to get something out of something. Okay, I mean, even to differentiate is like that, but for example, if you have to derive simultaneous equations in sequences and series, when given that the first term is this and then the 20th term is that, then find the common difference. There you have to derive. That means you bring to life what was not necessarily given. It was implied, but you bring it to the surface. It was there at the bottom somewhere. But to differentiate, we are literally deforming. I would look at it that way. What is given, we're just changing its look. Unlike it was there, but it was in the bottom of the sea. Now we brought it to the surface. That is deriving, because we're getting what was already there, but not necessarily given it nicely. But when we differentiate, we actually distort something. We're changing something, you know. So here, when we are doing the derivative, we're actually differentiating. We're not necessarily deriving. Okay, so it's more like to sift something, if you think about it. When we talk about deriving, we're saying we're bringing to light, or we're pushing something into the spotlight so that we can see it. But differentiating is more like sifting, because as you can see, when you differentiate, we're taking out constants in a way. Certain terms disappear, others are kept. but in a different format. That's like sifting something. Because if we mind something, or we go and get maybe tea, there will be grass as well and other things. So if we sift that, either by doing concept of fractional distillation, using the advantage of molecular weight differences, so that something that sits at the bottom is what we want or not what we want, doesn't matter. But as long as we separate, so it's more like a separation. So be familiar with the terminology so that when you converse, you actually say something that would be understood even by someone who is, from a different curriculum of some sort. Because maths is more of a universal language. It's just the symbols that we use in different parts of the world. But you will see that there are some common ones. Others are strange because everyone is trying to be special or look different. But at the end of the day, if we're doing similar operations, we're doing similar things, we mean the same thing. But hey, look guys, there's nothing wrong in being wrong, because I'm also wrong sometimes. It's just that we need to make a habit of constantly trying to improve, even if it's not for any gains whatsoever, but so that we become as perfect as we can be. Because that way, that means whatever we will develop, whatever innovations we can, venture into, they will stand to be as perfect as they can be. But if we always become complacent, I'm no master of this and that, it doesn't matter, you understand the implication, it's okay, I do, because we're in the same context. But do you think someone who's not would understand you? They would not, okay? And the idea here is to make sure that what we do and what we say can be followed by someone else elsewhere and still be looked at for the same meaning, right? Of course, guys, it's all about the pride in what you do rather than, the necessity to do it in a particular way or say it in a particular way. If you take pride in what you say and do, and you want anyone to look at your work and not have something negative to say, then you will make the effort. But if you are those people who I call hooligans, which I tend to have features of hooligans myself, then you don't care who says what. It's okay. It's how you see yourself. Anyway, guys, let's go on. It says now calculate the maximum speed that the cyclist reached on his ride. Now, of course, once you hear the word max, it means, differentiation. So that means we are going to differentiate this expression for speed. And from there, we solve for t. And after we've solved t, then we put it there. Now, a grade 11 doesn't know how to differentiate. We just complete a square there. And we take the maximum, the t value that we would get. So I'm going to show you two techniques so that if you're in grade 11, you don't feel like you cannot do this, okay? If a question like this is popped, a grade 11 should be able to answer at least 10.1. But 10.2 might not be feasible for a grade 11 student. All right, so what do we say now? We know that s prime of t, don't know why I'm hungry now, writing crazy. I tend to have intention tremors when I'm hungry. I'm that guy who depends on sugar to stay awake. But it's not doing me any good because it's chowing my testosterone, eh? And if I lose my testosterone, it's not fun what happens next, okay? You can't be fat and all that. And lose all kind of things and nice things. I can't lose these nice things. Okay, guys. So we know that for maximum speed, it is such that the second derivative must be equal to 0 because we're differentiating what was already differentiated. So we're going to say s double prime t must be equal to 0. This implies that when we do differentiation here, it's going to be minus 6t plus 18 is 0. Therefore, t is going to be equal to 3. Now t is time in hours, so this is 3 hours, but since this is an intermediate answer, I don't know if you have to show that, but whatever. Now if we say this, we can say then the maximum speed is going to be equal to s prime at 3, which is going to be minus 3 into 3 squared plus 18 into 3. Now this is going to be in kilometers per hour. So minus 3 into 3 squared plus 18 into 3. This gives us 27. So we get 27 kilometers per hour. But for to learn to write things properly, if you miss this kilometers per hour, if this is not written, you lose that mark. You will lose a mark. Of course, guys, doing the actual differentiation is a mark, right? Right. And essentially getting the answer there is proper, and getting the final answer with the right units. That's how we get the marks. Now, what would a grade 11 do? A grade 11 would say, well, I know that s at t is minus 3t squared plus 18t. Now this means I can take the negative out. Of course, I need that out as well, so it's going to be minus 3. Sorry, not minus 3t, but minus 3. Out we leave t squared minus 6 t. Okay, this is going to be minus 3 into, we complete the square, this is going to be t minus, we half this, we square it, and then of course we've got 0 here, plus 0 now, and then we immediately subtract this squared. So we then simplify, minus 3 into t minus 3 all squared, then this is going to be minus 9. Then we redistribute this. What do we get? We get minus 3 into t minus 3 all squared plus 27. And can you see this is the maximum value at the turning point? So from here we can say, therefore, maximum speed would be equal to 27 kilometers per hour. Okay, because that's the y value at the turning point of our quadratic. So a grade 11 can handle 10.1 that way. Or in grade 11 we can just say maximum speed. If we want to do it directly, maybe let me write it differently so that you guys catch the drift. Maybe one can easily say maximum speed is going to be equal to 4ac minus b squared all over 4a, just to do a simple one-step calculation. 4 into a is minus 3, c is 0. Remember, it's not there, so it's 0. Don't forget it. You will be dead if you do. Well, remember, this must be in standard form. ax squared plus bx plus c. Now here we just need to consider the 0 there. If you forget it, you are dead meat to be fried. You get it? Yeah. Sorry. So let's see, what do we get? What must do? What must do? What must do can happen? So this is minus 3. Of course, that's 0, guys. So this is minus basically 18 all squared divided by 4 into minus 3. It's still 27. So this is 27 kilometers per hour. Please don't forget the units of measurement. So this question is easy, guys. As you can see here, all that matters is this C there because it wasn't there. And then the rest of the general substitutions. That 0 we determined. That's why we mark it in the final answer with the right units. Okay? That's how we mark this question. And of course here, if we complete the square, writing it in vertex form is what is mark worthy. And then we get an answer there. Is mark worthy, you know. And of course our 0 there, because that 0 is important. It wasn't there, but we always write this in standard form, because if you miss this here, you will be doing wrong calculations and you end up suffering. And of course, you saw how we marked the first one. So that's easy. So this is just me trying to expand this. Otherwise, it's a very easy question to handle. But now let's deal with 10.2 nicely. 10.2 says, calculate the distance between town P and T. Now, this is a very nice question. Obviously, guys, once we want the distance between the two towns, now we need to be very smart about what we are doing. Since we see that the distance is a cubic function, like so. Now this cubic function, what type of a function is? We will appreciate that on the Cartesian plane, looking at the value of a being less than 0, our graph would start stuff like this. And of course, because we're missing this middle term here before this d, so this means the turning point is also the y-intercept. So whether this is negative or positive, we don't care. Let's just assume it's positive at this point. Our graph is going to be doing stuff like this and stuff like so. Okay, this is more like the graph that we can get. But then if d does not exist, if we say this is 0, I mean this is a possibility, so then we can do this. Okay, this one is trying to defeat me, but let me try to get this right. This graph is going to be stuff like that. I don't know what's cooking now. So this graph is going to be stuff like so. Okay? Now those are the two possibilities. So you see, when you have something in an applied format, it can horrify you. If you are not very careful in what you do, you just do for the sake of doing. There's a lot of thinking that needs to come in and a bit of practicality in there. Now look, if we say that d is positive, because it makes a bit of sense for it to be like, but I mean d can still be negative. It's not a big deal. That we can see. Okay? It can still be sending the same message, so to speak. But now let's look at it this way. What is cooking here? What is cooking here is this. Now we need to think about it. If we're saying we want the distance from one town to the next, then it means we have to appreciate the fact that whether this person was moving already and has moved a particular distance already, which would be up to that turning point D, this person is going to move some units upward anyway. So this could still be this town right here and then the next town. So this could be town P at that turning point, and then at the other turning point is town T. So this would be D plus whatever we get up there. Okay, if we think of it that way. Or we can simply say this town P would consider it as 0, and then town T is that next turning point. Why the turning points? Because the gradients are 0. And that means the speed is 0. So it means if we moved from 0 to 0, we increased our speed up until we got to 0. So this already tells us that this is likely to be the distance between the two turning points. So if you don't really think about these things, guys, you will be like, how am I going to do this? But if you think about it, you will do it. So now this antiderivative is necessary here, that concept, if you think about it. Okay, let's deal with this. So we were given s prime of t is minus 3t squared plus 18t. Okay? So this implies that s of t is going to be, basically we reverse this, it's going to be just minus t cubed plus 9t squared plus d. Because we don't know whether that d is there or not, but all we know is that the other term is not there. To make sure that the y-intercept, if it exists, it's also a turning point. That's what we'll appreciate. Okay? Great. And now this would make sense, because if we're saying we're starting at 0, we can only increase the speed up until we reach the maximum, right? Which is the point of inflection. And then from the point of inflection, which probably is over there, then we will then decrease the speed up until we stop. It doesn't really matter how we decide, but this makes sense, the second scenario. But even the first scenario, it's not a problem, because we'll still get the same answer either way. So now, what is our job, guys? Our job is to find the x-intercepts, because the x-intercepts are going to help us to find the corresponding y values in the original, and from those corresponding y values, then we take the difference between those y values of the turning points. That should give us some idea about the distance between town A and town B. Okay, great. So I'm trying to think. We can say, however, I'm teaching you maths now. However, what do we know, guys? We know that basically we want this thing. S at t equal to 0 implies that minus 3t squared plus 18t is equal to 0, which would imply that we take out the highest common factor, minus 3t into t plus 6 is equal to 0. We can see that t must be 0 or t must be minus 6. But now remember, oh, wrong factorization. This should be negative now, so this becomes positive. I was already rushing to reject, but now time t0 doesn't make sense. So now, guys, we know that this turning point t there is at time 6 hours there. So this is the time it took to travel, essentially, from town A to town P to town T. Because at the end of the day, if you think about it, it doesn't matter whether we said P was up there. The most important is that to travel from that y-axis to where T is on the horizontal plane is exactly 6 hours, so to speak. So once we find the hours, because we can't have T0 here. So to travel from, like that, how long did it take? 6 hours. Therefore, just take this and plug it there. Then we will get what we want. Okay? We can say, then Okay, now since we wrote it like that, we can say then we understand that s at 0 is going to be minus, it's just going to be d, right? And s at 6 is going to be, I'm going to just write the answers, guys. We can substitute. I'm tired now. So this is minus into 6 cubed plus 9 into 6 squared. So that gives us 108 d plus d. Okay, since we have d. So now what do we want? Remember, this is the turning point. This is another turning point. We can then say, therefore, distance from A to T. No. We don't have A, from P to T is going to be essentially I'm trying to write a formula really, guys. It's going to be s of 0. No, you take the bigger one, s at 6 minus s at 0. Maybe let's use an equal sign. This is equal to 108 plus d minus d. And now the d's take care of each other. So the distance is 108. But remember, now this is in kilometers. Of course, this is when I don't want to discard my d, because there's no knowing whether it was there or not. But since we know that that d is along the y-axis, we know that is exactly at t0. So this is why we don't really bother whether we shift this down there or not. It doesn't matter. Okay, guys, so there are many controversial issues though. If you think about this, who said this is the vertical distance? As in, town T is directly above town P, for example. Who said that? Why not use the distance formula instead? You know, and say this is the diagonal distance. Nobody said how it is. So these are some of the issues of applying certain things. Hence, it would make a bit of sense to say, then the second graph here would make a bit more of a fitting model, because we'll assume that you started from t0 at speed 0, then increased the speed to a maximum at that point of inflection, up until we then decided to decrease the speed as we got nearer and nearer to our destination until we stopped. That one would make sense. But again, if we think about it, does the distance formula give us 108? Because then we will have 0 and 0, and there at the turning point we will be able to have the corresponding y value, so to speak, assuming d does not exist. Then we can use the distance formula there. Then we can get an answer. So a student who pursues it that way, I don't think is wrong, because that's a possible distance as well. Because this could be a distance directly above the other, or in a diagonal fashion if we think about it that way, using those points. Yeah, I think anyone who did that would win. But the problem would be to put d in there. D would be a bit of a situation, because we cannot, in this case we cannot guess it. And if we cannot guess it, I think it's best if we handle it this way, or use that highlighted graph, this one. To use that graph for the model, then it's much better. So again, questions like this, you wonder if the quality assurer sat down and thought about these kinds of possibilities, because the memo might come saying something else and not feature this possibility that one could have just looked for those coordinates of those 2 points, because now we are going to use the Cartesian plane since these are shown to be on the Cartesian plane. And then of course we can adapt our axis here and say this is time, and then instead of y we can say that would be s prime, s in terms of t, or st, because we are adapting this. Now if you did that and you saw that this is more like doing this on the Cartesian plane, why not do the distance formula? Because then those towns are placed like that. So that would also make sense. But again, you would have to provide that sketch to show that this is the best model. This is the fitting model. This shows your critical thinking. It shows, again, your understanding of how to apply things from theory to some kind of a practical situation. At the same time, knowing that I'm dealing with the Cartesian plane here, then it's safer to use the distance formula rather than to assume the distance between the two, because nobody said town T is directly above or they are in a straight line of some kind. I don't know, man. It's very difficult to sit with one answer. But yeah. So do think about those possibilities. In fact, let me just feature this answer since we are talking about it, so that we don't go around in circles. Let's say here, let's say given that s prime of t is minus 3t squared plus 18t. This implies that s at t is going to be essentially minus t cubed plus 9t squared. And of course it would make sense to say there mustn't be anything elsewhere. We can leave it at that. There's nothing bad about it that way, because the next term was not there, so it's likely that the other one is not there. We can say here, which also implies that this function, sometimes you can draw this into your answer. Remember, whatever means we used to solve our problem, if we can demonstrate, the examiners are very happy with us. Not the examiners, the markers. Right, so we can say the best model here is this. Okay, let's take you down. You're trying to mess with me when Adamela Mona, man. Scampor. Wabon. So let's say this is the best model for our graph, because we'll assume that at the origin we have town P. And we know that the next town is going to be at the turning point, because we understand that the gradients, because we know that the derivatives is going to be 0 there. It would make a lot of sense. Of course, we can say this is t. This is going to be s of t. Right. This is the fitting model. We can assume this is the case. Now everything we do, we just do. So we want to know what is the value at t. We can say then, however, as we have done above, we know that essentially s prime of t equal to 0, or we can even say at t and p. Let's put it that way. We can say at p and t it is such that s prime of t is equal to 0. These are the turning points. Right, so this implies that now minus 3t squared plus 18t is equal to 0, which implies minus 3t into t minus 6 is equal to 0. I'm rushing this, therefore we know that t is equal to 0 and t at t is 6. Right. We can say therefore s of 0 is going to be 0, or s of 6 is going to be, what did we get? 108. Essentially, nice and easy. So this is 0 kilometers, this is whatever. But at this point, we're going to treat these as points. So here we can even make a comment that p is 0 and 0, or s, no, or t is essentially 6 and 108. Ne? And then a student could logically say the best approach would be to approximate a straight line distance between these two. Maybe let's choose the under one. So we can say the average distance would be something like that. So one can say PT average is going to be the distance formula there, right? Yeah. We write this thing. This thing can be done here. So we can have x at t minus x at p all squared plus y at t minus y at p all squared. Okay, I don't know if it is visible, but you will forgive me if not. So we know that x there is 6 minus 0 squared plus, we know that this is 108 minus 0 all squared. Let us see, what do we get? So this is going to be 6 minus, of course this is nothing but just 6 squared. I don't know why I'm suffering. 108 squared. So this one is still not so far. Actually, it doesn't lie. We get 108 comma to 2 decimal places because it wasn't stated here. It's gonna be 17 kilometers. Okay, that's not bad. It yields a similar answer. Okay, so one can still approach it that way. Fact of the matter is, rounded off to the nearest, it's 108 kilometers. So now I'm happy that this approach is not unsafe. Now it's okay to leave it, but think about these things, guys. These are things that can horrify you if you're not very strong at your work and you die a slow death. And you know what? We laugh at you, Tinabanye, because basically we told you so. So actually, guys, I think the mark is here, technically. And I would suggest that the other thing that matters here, whenever we factorize, doesn't matter what is the plan. Usually it's part of the 3-step approach. We get a mark in there. And essentially, I would say those are the 2 marks there. Lord, what can we do? Yeah, doch. I think these would be mark worthy as well. So 1, 2, 3, 4, and then 5. I mean, this is applied from elsewhere. There's too many areas. I mean, there's many ways one can figure out how to mark it this way. Okay. So this is not bad because it gives us the answer that we got, rounded off to the nearest integer. So I guess the quality assurer here can be forgiven for not looking at this, because if it gave us a totally different answer, I was going to scream. Of course, I would not scream per se. I would just say that should also be acceptable. Okay, let's do question 11. Now this is the things that give me headaches, man. I don't like probability. Zange ndayifunda nasesikolweni le nto lena, ndifigurishe out xa ndititsha nina. A certain number of learners are sitting for examinations in mathematics, tourism, and geography. Okay, I didn't do this thing. I did maths and geography. Okay, now this already, once we see these three categories, we know that we can talk about a tree diagram. We can do a tree diagram here. We can do, what is this? We can do a Venn diagram, but the best is the Venn diagram for this kind of thing. Okay, so let's have a look. What is the story? All these learners sit for at least one of these examinations. It means 1, 2, or 3, but there's no one who doesn't do this. So if we think of it in a Venn diagram, we will have circles here that are intersecting, stuff like so that everything fits there. Here on the outside, there's nothing, there's 0. So this is what this means. So it means these circles are exhaustive. The data is there. The sample space is going to be what is in these circles. So literally like so. So the sample space is exhaustive. Everything is here. There's nothing outside. Okay, this is the impression that this gives. So it helps guys to scrutinize given pieces of information, because if you don't even get the right idea. If you don't get the right idea, you don't even understand what's given, then it becomes a horrible situation. Anyway, let's not talk too much. Now the total number of learners who sit for maths is 22. Okay, here I know we're going to need this. It says draw a Venn diagram. Sometimes I'm not so sure which technique, if it fits 2 techniques. Look at the first question. Does it really want either one of the 2? If nothing is stated, then you go however you want. But usually a Venn diagram is the best one. So 11.1, we may as well just start by doing it. Okay, so we've got stuff like this, stuff like that, stuff like that. Okay, and we know that this whole shenanigan is doing its own things. Let's contour it a bit. Yeah, now we're going to choose that this is mathematics, geography, tourism. Is it tourism? Is it tourism? Yeah, let's look at the sample space. Sometimes it's nice to show it too. Okay guys, so we are told here the total number of learners who sit for mathematics is 22. So now that's just the total. We're not gonna do anything about it. The total number of learners sit for tourism is 16. Okay, we don't start with these anyway. We start with the intersections. Let's see. The total number of learners sitting for geography is 18. Okay, so these are the totals to consider as we move along. So let's see what else is in here. I told 5 learners sit for maths and tourism, but not geography. This is very important. So this means those that sit for mathematics and tourism, so this is this intersection right here. How many are they? 5. Okay, but not geography, meaning we're not going to include geography. Okay, 4 learners sit for mathematics and geography, maths and geography, but not tourism. So this is 4 right here, not 4, 3, sorry. Okay, and then we are told now 3 learners sit for tourism and geography, but not mathematics. So it's very important. The intersections are the best place. Now we're told 6 learners sit for tourism only. So only it's this space. But now what was the total for tourism? Remember, tourism was this whole circle. Okay, so we were told we're supposed to get what? 16. So we've got 9, 14. Now we're short of 2. So this means the intersection is 2. And the good thing is that the intersection is for all of them. Okay, so now we are good. So this means we can fill in these other missing parts. Now for maths, we're supposed to have 22. So we've got 9, 11. So there must be 11 here. Then for geography, we're supposed to have 18. So we've got 9 here. So there must be 9 out there. So how many are these? So that we can sort up our sample space. So this is 9 plus 3 plus 2 plus 4 plus 11 plus 5 plus 6. So they are 40. Please make sure these things are indicated, guys. I know it's easy to not take this seriously, but it's very, very important. But anyway, what was not given is this guy. So that's a mark. This was not given, that's a mark. This was not given, that's a mark. So I believe these are the 3 marks. Of course, the sample space is not really a big deal. It's given by what we have. Okay. Of course, the whole thing, guys, must be correct, for us to get full marks. If not, then we lose a mark elsewhere. Yeah. Okay, that's fine. We've answered that first 3 marks. 11.2 says calculate the probability that a learner chosen at random will sit for examinations in at least 2 subjects. So this means 2 or more. So this means the intersections. So it's going to be this. Okay, maybe let's use another marker. So this means it's going to be this, that. Those learners are sitting for 2, but that, because at least means greater or equal to. So it's going to be those. So we can just say probability of the event. Sometimes I just want to not waste time with a lot of things. So it's going to be 3 over the total plus 2 over the total plus 4 over the total plus 5 over the total. Okay. Now this is simple algebra. The denominator is 40. 3 plus 2, that's 5. Plus 4, that's 9. Plus 5, that's 14. 2 goes 7 times. Goes 20 times. That's it. You can leave it as a fraction. Or we can leave it as a decimal. You can leave it as a percentage. Very easy. So I would say this is good, and the final answer easy 2 marks. So 11.3. Let's see what is the story now. Now determine if the events sitting for examinations in maths and sitting for examinations in tourism are independent. Support your answer with a necessary calculation. Okay. Now let's see here. Let's say what is the probability of sitting for maths multiplied by the probability of sitting for tourism. This is going to be equal to, now sitting for maths is what? The total for maths, which was 22, over the total, which is 40. Sitting for tourism is, how many were they? 16 over 40. So what is this? Let's just put it on the calculator here. 22 over 40 times 16 over 40 gives us 11 over 50. We know though that, but the probability of not maths, but for maths and tourism was what? Now the maths and tourism thing, where is it? Maths, tourism, so it's 7 over, it's going to be 2 plus 5 over the 40. So this is 2 plus 5 over 40, which is going to be 7 over 40. Now we can see that these two, we can say therefore we know that A, product probability of M intersect T is not equal to the probability of M times the probability of T. You can say therefore the events are not independent. Okay, maybe let's write properly. I don't know why I have this intention tremor now, because it's hunger time. You can say therefore events events are not independent. Iyacimela le writing because ubhutiza ulambile. I don't know why I'm taking so long, guys. I used to do 3 hours, close to 4, but now I'm going all the way now. Phike kodwa ndirambilisho kwezulu lasehlotyeni eliqaqaze njengengqulu ngayazi balingqulelanda bevele inethe belibaneka lesimosha. Ndivele ndibaneke ndidudume nami ndibe yiloo nto nje inyakanyaka. Khala isiqhotho khona apho unethe imvula bese zantyala nje estratweni. Inyakanyaka ngemini yecawe. Okay, that's it guys. Easy 9 marks for this one. If we did everything well. So obviously folks, I think this one is key and that one is key. And to prove that, to make a conclusion, that's the 3rd mark, and perhaps these substitutions here are more important as well. Okay, that's easy 4 marks for that sub question with that total of 9 marks. Okay, I hope you guys have gone about it nicely. But this is not 9 marks, man. Is it? Yeah, it's 9 marks. Okay. It is 9 marks. This one we got 3. I forgot. Okay. Let's do the last one, guys. Oh, I got guys. This examiners too. So many questions, guys. I have to discuss everything. It's not fair. Okay, a company generates a 4-character code using 26 letters of the alphabet. That means all of them, and the 10 digits 0 to 9. Great. Now the code is in this manner. Okay, letter, digit. Okay, not a problem. Now let's deal with this 12.1. This one is gonna be easy. How many different codes can be formed if letters and digits may be repeated? Now this is a very important restriction. So let's see. We have 1, 2, 3, 4. Now how many letters do we have? 26. So we can put any one of them because we can repeat, by the way. And that means also here we will have 26. And the digits, Z9, Z10, sorry. So Z10 ganja. If we repeat, this is what we have. And of course we multiply these nicely. Okay, let's do it. So 26 times 10. In fact, we can just say 26 squared times 10 squared. So we get 67,600. What is that? Codes. I must felicity codes. We don't really need to write that. We don't have a problem with this. So of course guys, this one is an easy one. You get 2 marks nicely. So we can say that easy. or 2 marks for the answer only. This one, you can get full marks for that, even if you didn't show us how you did it. This one is a bit silly. Okay, now it says determine how many different codes can be formed if letters D, F, I, Q, U, and V may not be used. So this is now 26 minus how many? 1, 2, 3, 4, 5, 6. It leaves us 20 letters to choose from. Okay, not a problem. And then it says the code may not start. May not start. Okay, must choose a different color with a W and a Z. As much as these are there, but they're not at the beginning. So now that means to start, we only have 18 letters to choose from. Because if we eliminate those two, then for the start, we only have 18 letters to choose from. Okay. Now the digits, letters or digits may not be repeated. Okay, that's good. The code ends with an odd digit. Now this one is one of those questions that are a true headache. Okay. Now folks, remember, we've got odd and even numbers. Once we single out odd numbers, that means we also need to consider even numbers as well. So this one is a very silly question. Now the way I'm thinking about it, well, this is a smart question, to be honest. It's a very smart question. I'm thinking about it. How many different codes can we form? Okay. How to keyboard? I was thinking of separating things 1, 2, 3, 4. Now remember, for the start, we have how many letters? 18 letters to start with. Because out of 20, we cannot start with 2. But once we put 1 letter there, now out of 20, I want to deal with the letter issue now. The letters, if it's not 18 up as a qal, that was out of 20, by the way. So we eliminated 2. So we could only start with only 18. But once we put 1 down, any one of the 2 down, then here we can put them back. So from those 20, we will have 19. Yeah. So this one is a strange one a bit. Because remember, once we put 1 down, it doesn't matter which one it is, then we will have 19 letters because we bring back those others that we took out. And this one could be any one of the 20. Wait, any one of the 18. That would be 17 plus the other 2. Now it gives us 19. Yes, we are good. Now the digits may not be repeated and we're not given anything else. So here we will have 10 options, right? Because there are 10 digits. But then for the last one, we'll have 9 digits. But now we are told that this must be an odd digit. So how many odd digits do we have? We have 5. Right? They are 5. So this one is not that bad, eh? Why did I want to think about the other one? Yeah, man, this is simple. It's like this. It's as good as this one. Yane, give my tart. Let's do it. I mean, this is easy, mos. This is easy, mos. 18 times 10 times 19 times 5. Yeah, this one is definitely less than the other one, so this is now 17,100 codes. Okay, that's easy. That is easy. That is easy. That is easy. Let me double check. Sometimes I forget. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are eliminating. As for the digits, hey, yeah, I knew there was going to be a problem. Yeah, it's not as simple as I made it. I knew there was going to be a problem. The problem is here. Letter, digit, letter, digit. Now here the digits can be mixed at first. So this one is a problem. Kimatata, because we're not repeating, so we can't just rush this. Okay, now this is great. This is already suggesting something. We need to deal with this properly. Okay? We need to deal with this properly. Now this means we need to think about an even digit here and an odd digit. That we need to think about. You know? And then but why do I feel like I didn't start this right, man? I didn't start this right. Why do I feel like this is fine like this? I feel like this is fine like so. We start with the restrictions, right? 18 are the ones that can start. And the end is 5 because this is odd, odd, and odd. 1, 2, 3, 4, 5. So this, most important is to start with the fixed ones. Now once we have sorted those ones, then we can deal with the rest, because if we place 1 here, what is the story here? Hey bana, ekare batla ho nshapa jwale. Yeah, I know this one is a headache, guys. Am I safe to say if I placed 1, any one of these ones, from 10 digits, I will have here I will have 9 options. Is this fine? Okay, this question is doing stuff to me now. Is doing the things. Yeah, guys. Guys, I think we have a problem. We need to think about something here. Literally. We need to think about something. I'm not sure if I'm planning this right, but I think we need to think about something. Let's say, of course, let's just think about it. 1, 2, 3, 4. Remember, guys, we can have an odd number here. We may still have an odd number there. It's possible. This one is fixed for sure, but it could still show up there. This is what makes me tremble a bit. This one is not problematic because here we are fixed as well. Come on, Wennerman. Here we are fixed. We are not having any issues here. That one is fixed. This is the case. But we may still have a situation where this is like so. This may still be odd. Right? Right. But we may have a situation, I mean, this one is fixed. And this one is fixed. But we may have a situation where we have an even number here. Okay? As for the letters, I don't really worry about it. Now I'm thinking about this framework. Is it valid to think about it this way? Yes, I think so, because as long as the end is odd, but now when an odd number shows up there, we need to account for it. But now my question is, are we not going to find ourselves? Yeah, but I do think this is good, because it covers everything, literally. I think we need to think of these two scenarios. All right, let's do it. So 1, 2, 3, 4. So of course we established that we only have 18 letters for the start, right? Right. And then we only have 5 options for the end. And if we put one odd number here, how many odd numbers do we have left now? We will have 4. Right? And then here the letters are 19. Because if we place any one of the 18 letters, we'll have 17 letters left. Then we add the other 2 for this one. So it's going to be 19. I think this is fine. So we just multiply these nicely. And then we get this one. So 18 times 4 times 19 times 5. This gives us 6840. And then also we can think of this scenario 1, 2, 3, 4. Remember, it can still be any one of these 18 letters at the beginning, and then it's any one of these odd numbers. But now we have an even number here, so there's 5 of them here. Then there will still be 19 letters. So what do we get here? 18 times 5 times 19 times 5. So this becomes 8550. So we can say, therefore, number of codes is going to be this 6840 plus 8550. Let's see what we get. Okay, 6840 plus 8550. This is 15,390 codes. Okay, that's still less. That's still less. So, yeah, I think to separate is prudent, because we will run into some repetitions if we don't do that. We run into problems. So I'm not too sure if we're doing this right, but I do feel like this restriction here we need to put, and that restriction there we need to place as well, because that is what we're going to have. That is what we're going to have. Okay, whatever it is, guys, you think about it and you plan your way and you do whatever you can. There can be some truth into something. So obviously this should be a mark, this should be a mark, and this should be a mark. 3 marks. And what is the story now? It was 4 marks there. I think for any one of these things that we did now, the even and the odd, whatever, so we can get an extra mark. Let's just put it here, because I don't see it. Anyway, let's move on to the last question. Okay, that's it. 12.3. Now 12.3 says the company wishes to increase the number of 4-character codes formed in question 12.2 by allowing letters, to be used. Now calculate the percentage increase. in the number of different codes that can now be formed. A percentage increase. Yeah, these guys are percussing us now. So we're bringing back now these codes. This is 1, 2, 3, 4, 5, 6. Okay, so it's not a problem. It's not a problem. We can just find out what is going to be the story here. It's going to be 1, 2, 3, 4. Now, yeah, but I think we still need those two scenarios. Now we will have all the 26, right? So it's 1, 2, 3, 4, 5, 6. These ones are back. 1, 2, 3, 4, 5, 6. They are back. So out of 26, we can only start with 24, right? Right. And of course, we still have 5 options for the end. And then, now we can choose, if we placed one odd number there, we will have 4 options for the other one. And then, once we put down 1 here, out of 24, any one of the 24, we have 23. We bring back the 2, we get 25 here. But why is this question 2 marks, man? Hi. Hi, ngumhlola. I think I'm doing something I don't need to be doing here. Now it's starting to question my question. It's questioning my question. It's questioning my question. So this is 12,000 codes. I don't need to write in the intermediate. We can say here also we have a situation where we have 1, 2, 3, 4. We can start with any one of the 24. But the end is still fixed. But now of the even numbers, we have 5 there. And then the letters are going to be 25 anyway. I don't understand now what I'm doing. 24 times 5 times 25 times 5. Mazlimezi again. This is 15 scored. Therefore, the number of codes is going to increase now to 15,000 plus 12,000. Okay. That becomes 27,000 codes. Now from 15,000 codes, we increased to 27. So we can say, therefore, the percentage increase is going to be, we take this one, it's going to be 27 scored minus the 15,390. We divide by the original one, which was 5390, multiplied by 100%. Let's see, what is this one? Minus 15,390 divided by 15,390. Then we multiply this by 100. So this increases by 75%. 75.42% to 2 decimal places. Okay guys, yay. Andanobanibalezo mqala mke apha andikho sure iyandibhobanisa kancinci le question. But hey, an exam is like this, guys. You just use what you understand, your principles, because if you don't use your principles, then you don't even have a clue what you're doing. Can you see this is just 2 marks? As if it's just that easy, you know? And yet it's not that easy, unless I complicated my life. Now I'm starting to think this approach is probably not safe, you know? I'm starting to question my approach. Yeah, my approach, guys, is worrying me a bit. I'm worried. Lambile futhi sifuke seniphethe, guys, yo. Ngakhohle lapha ngaphuma nje nirust enzima kabi. Angavula kwesisifuba, yo. Okumzimba obuhlungu nje. Khohlela ngathi ndiyintsha. Wakwayiva loo nto. I'm coughing like a dog. Anyway, folks, this is as far as I can go with this. But you know what? Seeing the 2 marks here, it makes me worried that my approach is probably not on point. I worry that my approach is not on point. Because why 2 marks when there's so much to do? I mean, just 2 marks. Anyway, it looks like this is the number of codes that we needed. Or maybe just this whole shenanigan and the final answer, just 2 marks. Ayingeke bafethu. The last 8 marks angazi nami ukuthi kwenzakaleni laphana, nani senizozibonela. Nayo le niyangixaka nje. 2 marks qha. Isipane sibhaya so. Maybe I'm overthinking things, it's possible. But hey guys, this is as far as my discussion of this memo goes. Of course, I'm not a robot. Even a robot, depending on who was coding on it, it can just come up with some crazy answers. So if you pick any mistakes here, please don't believe those mistakes just because it's me writing. I'm a person who can make errors. In fact, you will see that I have been making lots of errors throughout making these videos. Main issue is I don't have a chance or enough time to sit back, watch these videos. Again, your brother here is electronically disadvantaged, if I can say. So I don't know how to edit these videos. I don't even edit them. I just make a video and put it out there. I don't edit, because if I could even shorten the videos, because you know that's what you can do to make it go faster, maybe, so that it uses less time. You may find that within 2 hours the video could finish, but you will see certain things it will rush. That's some of the things that one can do to make this look fast, even though they are not as fast, okay? And maybe where I made errors, if I discover, then I can actually show you that, hey, watch out, that is a mistake. But I mean, if you've been paying attention throughout, taking breaks where necessary, you will even pick up my mistakes before I move on to the next question. So you will already have known. If you're not so sure, please, the comment section is there for you guys to voice out your concerns or your questions or even your suggestions of better approaches. Remember, we are a community that is trying to improve each other. So if you have a different opinion on how to solve something, please just showcase it, because it just might be the best one for everybody in this community. So we always are trying to look for the best approaches. But if not, then we use whatever means necessary to get to our answers. As you can see, some questions can really stretch your mind. Probabilities is one subject I hate in maths, because I never even was a good gambler. I don't even want to gamble, because you know what? That's just the concept of probability right there. Gambling is not my stuff, so I don't do it, because I worry about losing what I've worked hard for. You see, when you work hard for your things, it's not that easy to gamble with them. But when you don't work hard, of course, you can gamble and get lucky and make a fortune. Who knows? The problem is that gambling in the long run, you will lose out anyway. You're not going to win forever. So to work for your things, you just need to find smarter ways to constantly increase on what you have, and perhaps you might get there. Anyway, guys, I hope we are together. But I'm worried about my last two questions. The fundamental counting principle is doing things to me now that I don't believe, that I cannot believe, because my only problem, guys, is that I feel like my approach is repeating. You see? I feel like my approach is repeating. So, but anyway, no, it's not necessarily repeating. Because what it means is that if a letter appears here, it must not appear there. That's all. That's all. If any letter appeared there, it must not appear there. If a digit appeared here, it must not appear there. That's just what this is. Okay? So, yeah, I think the approach is right. I think the approach is right, because these codes, even if they start with an A, but if this number is different and that number is different, then the whole thing is different. So yeah, guys, I hope this is it. So we could see that when we could repeat and we didn't have restrictions, we had about 67 codes, so to speak. I think the other way to do this, which probably avoids this problem, we could decide, let me see, maybe this is the easier approach. We could perhaps decide, but again, this is, for me, no, it's not gonna work. It's not gonna work. It's not going to work. Because I was thinking of a different approach, but now I'm not thinking straight. For me, we could just use what we have here as the restrictions, right? But decide not to end with this odd digit. But again, it's going to create problems if we don't do that separation, because I was thinking we could take this total, but now this total is different. There's repetition everywhere, and we were using everything without any restrictions. But now if we could accommodate these restrictions right here and get some total, and then maybe take the even ones that end even, then we subtract from the total, we could get what we want. That's what I'm thinking. That is what I'm thinking. But now, as much as we could restrict the even ones, we could say an end must be even, and say like so. Say this one must be even. We could restrict here and still apply the rest of the restrictions. But then, what would be the total? What would be the total? Yeah, I'm thinking of this approach. Look, I do believe we could create a total here and say this would be our total. I'm not sure, guys. Say here, this is even, right? We want to restrict this to even numbers. And then, of course, we're starting the same way. We can't start with the W and the Z. So, we essentially have 18 letters to start from. And then once we start from this, once we put down 1, we have 17, but we add the 2 back. So we will have 19, right? Right. And then if this is even right there, okay. Now this will ask for a separation still. it still asks for a separation. I don't think it's gonna work. Let's just leave it the way we have done it, guys. It's just me trying to think out loud because I am not very comfortable with my answer. I've never been so unsure of my answer. I'm usually the guy with the overconfidence, if you ask me. I don't doubt myself at all. But anyway, I'm human, guys, if there's any craziness. But I think the plan works because I don't see how we would account for certain things. I don't see. And in fact, we can see that indeed, if we just changed a bit here, there was an increase indeed. So let's accept or not accept. Doesn't matter. Guys, our discussion is over. And I hope you leave a like, thumbs up. And you might just want to consider subscribing to this channel because every now and then I'll keep dropping some good things. And the reason for you to subscribe is so that you don't miss out. Because every time you visit, if you're subscribed, you will be able to access all the content. But if you're not subscribed, you will just see the popular things only. And in fact, you might as well just hit that notification bell, even if you have not subscribed. I don't think they limit you. Do they limit you to subscribing first? Because I see a lot of videos I never subscribed on, but just watching. Every time there's a post, I'm notified, even if I didn't hit the notification bell. So whatever you do, guys, as long as it is going to help you study. But yeah, I will be infrequent in this platform from now on going forward. So it would help you to subscribe and hit the notification bell just to be on the safe side so that if I drop something, you see it. And I can tell you guys, if anyone has been watching my videos, as I said, this whole paper could have been a breeze for those students. Of course, you can see where I myself get a bit shook. You would probably also get shook there, but I mean, you're smarter than me, remember? Me, I'm just doing fantuka stuff here. You guys are taught, practice, this is all you eat. Me, I'm distracted by many other things, which I cannot make excuses with for sure, but that's the story. So, you would probably not get as stuck as I do, although you may be in doubt at some point. But I don't think you would reach the extent that I do. So this is just me there doing the things that I know how to do. And when I don't have a better way, I just do it the way that I see it so that I cover as much bases as I can. If that be the correct way, then we stuff it. We stuff it up. If it's the wrong way, then we stuff it down. And besides, guys, even if you lose here, you'll just lose 6 marks. I mean, 6 marks is not such an outcry. But as for the rest, you can see that it was sweet and sound, I hope, and that you understand things. So you know what, as the banks are playing you guys, when it comes to financial math, please play them back. Know that when you take a loan, take it for as long a period as you can, but make sure you read that contract. Don't just sign and take. Read that contract, and if you realize that it ties you to saying if you finish this early, there will be a penalty, check it. Go sit with that contract. Just take that whole thing. Sit down with it before you sign it. Okay? Check it so that if you find some money, you can be able to reduce the interest, you know, because trust me, the remaining balance is on the raw borrowed amount. It's not on the one with interest. That means if you can just put that money back, then you're spared from the interest going forward. So don't be played. Those people are smart. They know that there's a whole lot of issues with these calculations, but these are the best models so far that we can use. So this is not just to pass metric, but just to understand things in general, because some of you are going to borrow money to finance your houses when you become professionals or adults. Or finance your cars, but some of you are going to not have so much responsibilities. that so much money can be spared over a year. And now instead of paying a car for 5 years, you can just pay it for 2 years or 3 tops. Then you can spare yourself of 2 years of interest. And that interest comes back into your pocket, and you get to live better. So sacrificing for your first 3 years to make sure you don't have any more interest for the next 2 years. That means within those 5 years, you would be just as rich as you want to be. Because this is money you would have lost anyway. Now if you get to keep it, it's even better. Because now you're in a very good position. The car you own, then you've been able to save money instead of losing all that money while you own that car. And that means at the time that you would have been paying off that loan 2 years later, you could even be selling this car if you don't like it anymore. Take that money and buy a brand new car without now needing a finance option. Because guys, don't work for the banks, please. These people are ripping us off big time. And because we don't know these things, we don't understand these things, we suffer all the time. So don't become victims. The economy is not doing well globally. People are hungry everywhere. So you don't want to be part of the statistic, even if you're not really rich, but you must not need money for food, money for clothes. Of course, decent clothes. But if you want to be careless, you can go for expensive clothes, but there's no difference. They cover your body. You don't run around naked and indecent. Be reasonable with yourself. There's nothing to wearing an expensive cloth. I mean, you can buy your Gucci for 50,000 t-shirt, whatever. It doesn't make any difference to me wearing my 200 rands t-shirt. If it's clean and brand new, I'll still look fresh and beautiful. You can wear your expensive stuff, but I haven't lost 50,000 for just that. I can buy as many as I want and still not even get to 5,000. But again, if you want to impress people, because for me, expensive clothes are just for impressing people in the world. Because what value are they? They're not of any value. Because if a cloth from Pep for $80, or even amasekeni la athengise park station eJozi, if unxibile ndoda impahla entle, the purpose is to cover your body in a decent manner. That's all. Then if you clean, neat laa nto ihlanjiwe, ayiniwe, sifake ilista soft, wafake perfume yakho nowakamnandi. Where is the value of wearing a Gucci? I don't see it. Just a stupid idea in people's minds. Because even if unxibe ezo nto zakho ezimbejembeje zizawungcola, umntu uzafika achithele ngekofu phaa, seyimdaka laa nto, ezinye iziteyinzi zingayimosha naphakade. So uba miserable basically, because accidents happen. So living in an expensive manner, that means minor accidents are going to cost you a fortune. So why would you be wasting money on such things? But if you have money to spare, why not put it away on some investment option and not touch it for the next 5 years? Because it's clear you don't need that money if you're going to buy expensive clothes. It means you're just playing with it. So you might as well put it away. Who knows, you might just be able to buy a farm and create some employment for your family members who are not educated, or even your community that you come from. Remember, that community raised you by instilling principles, by teaching their children so that they don't influence you to be stupid as well, because a community like that provided an environment for you to grow easily without being influenced negatively by anybody. You owe it. So you might as well just start a nice shop there. Go down on the prices, because you'll be getting these on subsidy anyway from the firms. Or if you have a farm, you will even be planting these. To buy a seed is cheaper. To grow it is even easier, because there's rain, the soil, there's nothing much to worry about. So it's much cheaper. So you come and sell it here cheaply so that these people can eat and be fresh and be productive. Make it easy for the society around you. Then you will make a fortune. Now, I mean, when you make a fortune, remember the 50,000 Gucci hat you want to buy. It's like buying a 500 something when you are a multi-billionaire. Now you can start to live large, because why not? There's no loss whatsoever, because what we would call a loss to you, it's like a minor dent, like it is when I bought my cheap clothes. When they get scratched in the washing line there, or the birds puke on it or poo on it. I mean, it's a minor setback because I can afford it. Now, when you can afford an expensive lifestyle, so why not leave it? You can buy yourself a private jet. It's nice. It's even more convenient this time because it's no longer just a cost. Because even if it breaks down, you can fix it. If you don't like it, you can sell it and buy a new one that is fresh and faultless. But you don't want to do these things with a little bit of fortune that you've just made. You might just lose it all and come back to suffering with the likes of us. Hey guys, I barely leave video now. Bye-bye. I'll see you guys again next time. And goodbye. I hope you enjoyed even the ramblings. But if you hated them, I apologize. This is just my nature. I just talk. I like to relax while I give what is good. To rush it, it means it's not important. But to give it nicely, it's for you guys to digest this thing, to understand this thing. And of course, I speak about a lot of things. I don't just do maths. I talk about life in general, some pressing issues currently. So you can call my videos an all-in-one if you like, because actually they are. Anyway guys, bye-bye. See you next time.